Do you want to master MATLAB and transform your data into powerful insights? Or you are struggling with MATLAB for your engineering, data science, or a research project? Do not worry. This complete MATLAB course is the solution to all your problem. In this course, we are going to cover basics of MATLAB, programming in MATLAB, regular 2D plot, 3D plot, spatial plots, different operations with matrix in MATLAB. We'll learn how to solve different equations in MATLAB. Then we'll see how to import data and how to export data from MATLAB and many more. So without wasting time, let's get started.
So let's get started with MATLAB. Let me tell you that MATLAB is basically a matrix laboratory. There are so many literature and so many things available on the MATLAB, so I'm not going to talk too much about pros and cons of MATLAB. Just to give you brief information, and then we are going to start directly with the interface of MATLAB, and we will understand this dashboard of MATLAB. So MATLAB is basically a matrix laboratory. The purpose of MATLAB is to perform engineering and scientific calculations and analysis. So this is the basic purpose of MATLAB, why people are using MATLAB. MATLAB is getting fame across the world more and more people in engineering sector and science sector are preferring to do research and design work through MATLAB. So MATLAB is important software to learn. Basically, MATLAB is developed by MathWorks and it is a proprietary firm, so MATLAB is not an open source available software. See why people are using more and more MATLAB? Because MATLAB has extensive library of predefined functions, and if someone had worked in some function and he is applying that function, he is giving this function to MathWork, then MathWork will add that function directly to the MATLAB, and then that function is readily available with the MATLAB. So you just click, connect and go. Another good thing about MATLAB is it can be interfaced with various hardwares like several processor, Arduino, IoT based device, data acquisition card. So there are various hardwares through which you can connect a MATLAB. And good thing about MATLAB, why people are using MATLAB more and why researchers and developers are going for MATLAB more is because it can reduce engineering design and development time as well as cost. Without wasting time and discussing too much about MATLAB and its pros and cons, now let's just quickly jump to the dashboard and let's understand what is the dashboard, what is what into the dashboard of MATLAB. But before moving ahead, there is a quick short question which is displayed on the display, so you need to answer me that question in below comment section before moving ahead. So answer me that question in comment section and then we will move ahead. Okay, so now let's move ahead. The things shown over here is the version of your MATLAB. I am using MATLAB R 2016A version. There are various versions available of MATLAB. The list of the version of MATLAB is written in description box. If you are interested to go through that list, you can check out the description box and you can have the list of different versions of MATLAB. Now we are going to discuss about this dashboard of MATLAB. So what thing is known as what, and then after in upcoming sections we are going to use each and everything in this MATLAB. So you can learn everything from scratch to pro in this MATLAB session. The next thing is this. This section is known as the command window. All the commands which you write and all the small programmings which you can do, you can write all that things in this command window. I will show you different examples, but that will be in upcoming sections. The section number 2, this section is known as the workspace. Whatever variable you assign for your script or for the commands, that will be stored in this workspace. So this is section number 2. The section number 3 represents your current folder. It represents the folder in which you are currently working. The next is this. This is the directory. This shows the path of your current folder. The next is this tabs. So this is the home tab, and there are various 3 tabs you can observe: home tab, plot tab and apps tab. Most of the time we are going to do everything using this home tab. And now we are going to discuss about various sections like this in home tab. In last few minutes you have seen different sections of MATLAB, and now we are going to dive deeply into that. As this is the introductory video, I am going to explain everything in brief, and in upcoming series video you will know more about that thing, more about that command, more about that particular section. So we'll start with home tab. In home tab, this button is a new script button. When you click this new script button, a new script will pop up and you can write whatever script you want to write in this section. Let me write a small script for you, a very simple script. X is equal to 10, Y is equal to 17 and Z is equal to X plus. Sorry, my keyboard is not responding as it is too cold here for us. So this is my script, right? If I want to save this script, I'll just go over here, click on save, and I can save this script. See, this is the dialog box popped up. So previously I have told you that this is the current folder. So all the script, whatever I'm going to prepare right now, this section or this script will be stored in this current folder, and the path of this folder is presented over here. So I am giving this as testing. Now I am saving this script. See, the path of my script is different. Where my script has stored is C user Mruduraj and testing.m. If I want to run the script, I just play this run button. This dialog box will pop up because the default folder of the MATLAB is different and the script where I have stored is different. So what I will do, I'll add the path. So I have added the path. The script has already run and I have the answer.
Hey there, I am thinking to provide 2 things. First, a free certification MATLAB course, and a second, in-depth structured course with exclusive content, exercise and support which goes beyond what it's available here, and that is paid MATLAB course. So please let me know by commenting or filling out the interest form in description box below whether you are interested in free certification course or in paid course. Thank you so much.
X is 10, Y 17 and Z is variable 27. So this is how a new script can be created. All the values will be stored in this workspace. In upcoming videos we are going to discuss more about workspace and variables. So in this section I am not going to explain more and in deep about this section, right? So now what I am going to do, let me show you something else about this script also. Here there is a arrow button. If you want to maximize this, you can maximize and you can have a good or a complete vision of your program or your script. If you want to go back, you can restore it from here, right? And if you do not want to use this, you can close it from here. So you will be back to your default view. If you want to open some new file, so go and click on new, and these are various types of file you can work with in MATLAB: script, live script, function, various examples, class, figure, app, Simulink model. We are going to discuss about even Simulink model also, but in upcoming videos. If you have prepared any previous files and if you want to open that, you can go and click on this open button. See, previously just few minutes or few seconds ago we have created this testing, and it is available over here. So these are the basic things you can do with MATLAB. If you want to find any file, you can click on find and type the name, and MATLAB will find that file for you. If you have two ready-made available scripts and if you want to compare that, then you can select both the scripts over here and the comparison will be created by MATLAB. I have told you initially that with MATLAB you can import data also. So if you want to import any type of data, you have to click on this import data button. Click on that import data button and a separate dialog box will pop up like this. See, these are the various file format which is recognized by MATLAB. These are the various forms of files you can import in MATLAB. So if you want to know more about this thing, just pause this video and go through the list which is presented over here, or else you have the MATLAB, open it and try and have some hands-on practice about this thing. Now let's move ahead. See, over here I have written a script, run it, and some data is stored in Workspace. So in future if I want to use these values of Workspace, what I can do is I can save this Workspace. Whatever data available in Workspace, I can save it as a .mat file, right? So that can be done using this save Workspace. New variable, open variable, and clear Workspace, that I'm going to discuss in my next video, because that is based on the variables. So at that time it is better to discuss it in detail. So right now we are just having a bit feel of this MATLAB dashboard. From here you can analyze your code, run and time, clear commands. Whatever command you have written over here, you can clear it from here, right? This section is for Simulink. If you click on this, a separate GUI based ready-made available functions, switches and so many things will pop up, right? So this is for a simulation purpose. So Simulink is a separate tool of MATLAB on which you can do various types of simulations, right? So now I'm not going deep in this Simulink right now, because in upcoming videos we are going to discuss more about Simulink. So at that time we'll discuss about it. The next is environment, the environment of this display. You can adjust the layout of this dashboard. This is the default layout. If you want to change it, you can go to 3-column layout, in which current folder, command window and workspace will be these 3 sections. Even if you want only command window, then you can switch it. So these are various various layouts you can go for. Now we are going back to the default layout. So these are the simple or basic things about the home tab. All these things we are not going to discuss now, because these things we are going to use in our upcoming videos, and at that time we are going to discuss about this thing in detail. The next is plot. Whatever script you are writing, right, and if you are plotting something, then you can adjust your plot from here. These are the various types of plots available in MATLAB, and you can choose any of this to fulfill your requirement. Various app support is also given with the MATLAB, and here are the list of various apps that can be supported with the MATLAB, but this section we are not going to touch now. MATLAB is like an ocean. In this world also there are various types of oceans, so it is not possible to fulfill everybody's requirement using one single video series, because MATLAB covers hydraulics, it covers electrical engineering, it covers digital signal processing. So in this video my aim is to give you brief about all these things, right, and you can build a basic level of knowledge about MATLAB. And then in upcoming series we are going to switch to Simulink and start doing simulations using this Simulink tool in MATLAB. There is a quick question for you on the display. Try to answer the question in comment section below. I'm waiting for your response. In today's session we are going to learn about the variables in MATLAB. So let's get started. Basically, a MATLAB variable is an object belonging to specific data type. As noted at the beginning, the most basic data type is one from which MATLAB takes its name, and that is the matrix. For the sake of simplicity, from here on a MATLAB, variable is basically a matrix. Let me take a variable and explain it to you that how does it creates a matrix of that variable. Here I am giving x is equal to 9. So the value of x is stored as 9. The variable, you can observe the value of x is stored in Workspace. Double click it and the variable will pop up. You can see here it is a 1 cross 1 matrix. Only one row and one column in this matrix. So variable will be stored in MATLAB in the form of matrix. Let me take another variable so that you can have a better idea of that. For example, we are taking variable f is equal to 1, 3, 5. And now you can see over here, double click on f and it is a 1 cross 3 double variable, 1, 3 and 5. So all the value of f will be stored as a matrix. Now if suppose you want to create a variable which has 2 rows and 3 columns. For that, let me show you how to write a syntax. For example, we are taking m is equal to 1 space 3 space 5 and semicolon. This semicolon represents that is the end of that row, and give a space and start writing again 7, 9, 11, bracket over and press enter. So this is how you can create a 2 cross 3 matrix variable. Let's double click m and you can observe this variable from here. If you want to make any changes in this variable, even from here you can make that changes. For example, instead of 3 I am taking 10, making 10, right? And now closing it. Now pressing M and entering. So you can see that the change is already here. So all these variables is stored in Workspace. For example, for your future use, if you want to store it, you can save this data of Workspace in .mat file. If you want to define new variable, then by clicking over here on new variable, you can define a new variable. Previously what we did, we had defined variable through command window. Now we define new variable through this bar, create and open variable. So here I am going to create new variable 2, 3 and 4. This is my new variable, right? And now I am going to save this. This is my new variable, right? And now I want to close this variable. So here there is one unnamed variable which I have just created, 2, 3 and 4. If you want to make any changes in this variable, you can make it from here. Instead of 2, if you want to make it 5, you can make it 5 and close it. And the changes in this variable can be observed from here. Now let's understand the role of this workspace for variables, and to understand this we will maximize the workspace so you can have a better view. In workspace you can see the name of the variable and the value of the variable, but there are still several things that you can see. Place your mouse over here, right click, and these are the various things that you can see. This is the class of the data. It is all these things is a double precision data type. If you want to observe the size, then you can observe the size of the matrix. If you want to check the amount of memory this data is using, then 24 byte, 48, 8, 24, 8. So these are the things which you can add to observe in your workspace. Now again, if you want to move to default value, go and click restore. There is a shortcut for this, Control Shift plus M. Control Shift M, it will maximize. Control Shift M, it will be on its original condition. For the same thing, command window, Control Shift M, it will maximize. Control Shift M, it will be on its original condition. So this type of shortcuts also is going to help you a lot. There is a quick question for you. Try to answer me this question in comment section below. Here I have provided the basic information about the variables, how to enter the variables in MATLAB. In upcoming videos we are going to know more about the different commands used in MATLAB. So as I have talked earlier, in this video we are going to know more about this workspace. See, basically what is the role of this workspace? Whatever variable you are assigning, that variables will appear in this workspace. Let me show it to you. If I am assigning a variable x with value 45, then this x variable will be stored over here. If I am assigning y 78, the value 78 will be stored in y, and that will appear in workspace. So whatever variable you are assigning in your script file or through your command window, that variable will appear in workspace. Now if you want to maximize this workspace, you just click this arrow and you can maximize this workspace. Now let me show you something else. Let's just restore. Now let's understand this thing.
Hey there, I have provided this complete MATLAB course for free, and I hope it is very helpful and valuable for you. After learning from this course or after completing this course, if you find it valuable for you and if you want to appreciate my efforts, please do consider donating. Your support will help me invest more time and resources into making even better tutorials and provide valuable learning experience for you. You can find the donation link in description box below. So thank you so much for your support.
You have created these two variables. For example, if you are created another variable with some equations, we are going to use simple equations initially. Z is equal to x plus y, and the value of z variable also is stored in workspace. For example, in future you want to carry on your program from this stage. To carry on the program from this stage, you require all these variables. But once you exit this MATLAB, all the variables from workspace will vanish. It will be removed from workspace. So if you want to use these variables for future use, what you can do, you can save this workspace data, and for that you need to click on save workspace. A separate window to save the file will pop up. You select a folder where you want to save it. I'll go to this PC and then data, and MATLAB work and workspace. I'll name this testing. We are testing this thing, right? So I am giving the name testing. So we have saved, right? So whatever data we have assigned in workspace, we have saved this data as testing name. Now I am going to give you a small command to exit the MATLAB. Just write exit exit and press enter. The MATLAB will close. This is my OBS setups window. I am going to open MATLAB. Okay, so we have again started MATLAB, right? Now we have given three variables, x, y and z. So let me write x. It is undefined function and variable because the value of x you cannot see in workspace. So whenever you exit the MATLAB, whatever values stored in workspace, that will be automatically removed from workspace. It will vanish. So let's just try for y as well as for z. So each of these variables is not assigned. Now what we will do, now we will import the data. So we'll click on import data. A separate window will pop up. Now we'll import the data from the workspace folder. Testing is our file. We will open it. So select variable to import using checkbox. Whichever variables we want to import, we can import either them separately or all. For example, if I want to only import z, then I will click z only. Or else if I want to import all of them, then I'll click mark on everything. Just click on finish, and now you can see all these variables are assigned over here. So all the variables recall in this workspace, and now if you say x, then it will show the value of x. If you say y, it will show y, and if you say z, it will show z. So this is interesting thing about workspace, and this is how you can store your data in workspace. Now let's see something else. Just maximize this workspace. The shortcut key to maximize and minimize this workspace is Control Shift M. Control Shift M, it will be minimized. Control Shift M, it will be maximized. There are still different values which are available, which you can see for these variables in this workspace. There are still many things which you can observe in this workspace other than name, value and size of the variable. Just go to this line, right click, and all these types of data you can see for this files. Bytes, class, minimum value, maximum value, range, mean, all these things you can see for the variable you are assigning. Let's just minimize it and assign a new matrix or new variable. A is equal to 1, 2, 3. This is a variable I am assigning. So value of 1, 2, 3 is assigned, right? Now you can see value is 1, 2, 3, size is 1 cross 3. The size of this variable is 24 byte double. Minimum value in this variable is 1 and maximum value in this variable is 3. Range 2, mean value is 2. So you can see all this important information in this workspace about your variable. So this is the brief about workspace.
Hey, if you are using MATLAB the same boring way, then here is the chance to give a new look to your MATLAB. You can customize so many things in MATLAB. You can change color, style, font type, font size. So many things can be customized in MATLAB. So in this video, I'm going to show you that thing. So without wasting time, let's get started. Okay, so this is the dashboard of our MATLAB,
And here you can see workspace, current folder, editor, command window, so many things you can see on the dashboard. So this video is especially for appearance, and in order to work with appearance, first you need to go to this home tab, and in home tab you need to go to this environment. So whatever we are going to do in this video, everything will be from this environment. First, quickly I'll show you how to adjust the layout, and then we'll jump to the next and important section. In layout, there are varieties of layout. You can select it from here. It is default layout, and then there are so many types of layout. This is my layout because I like to arrange everything like this, so it's my layout. If you want to set your required layout, you can very easily set it. First thing you need to do is just arrange everything the way you want, and then go to layout and then save your layout. Name it. I have named it as my layout. You can name it as the way you want. So save it, and just in one click you can rearrange everything the way you want, right? Then here command history, I have undocked it. We can even dock it, so it shows whatever command we have used earlier, right? If you wish, you can use it, otherwise you can remove it. And now we'll go for background color changing, font color changing, font style changing, right? So that customization can be done through this preferences. So let's go to preferences. In preferences, go to this colors tab. So first thing is desktop tool color. Here you can change the system color. It is by default, it uses systems color, right, which is like this. If you want to change it, just unclick it and you can set the text color. Right now it is white. You can see over here all this text are white and the background is black. Once I apply it, all the changes will be applicable over here. So you can see the background has changed to black, and all the fonts, the code that I have written, that changed to white. Even I can change the font color if I want, let's say blue, then apply, then it's changed to blue. Let's make it white again, apply, it's white. Even you can change the background color, right? So there are varieties of things you can do with this, right? I just prefer system default, right? The next is syntax highlighting color. It shows important keyword, string, system command and validation sections. For example, any loop function, this for and AND, it's an important keyword, right? So that is keyword for that loop. So that will be in blue color. Why? Because it is set blue from here. You can make it purple, so you can see here it is purple now, right? So if any point of time, if you have any confusion that whatever changes I am going to make, exactly how it will look, so in this section you can see how it will appear. Then string, it is the string that we have written. You can change color from the string, right? It's changed. You can make it even black, right? So whatever color you want to make, you can make it from here. Now this is string. Unterminated string. Unterminated string means you have did a comma, but you have not terminated that string with comma. So the color of that string will be brown. That gives you indication that it is not yet terminated. And to terminate that is very important. So through this color combination, MATLAB indirectly giving us so much of hints, right, that there is still something is missing. So with this color code, we can have some idea about our program, whether the syntax is appropriate or not. Here it is the comment. Comment is generally green, and you can change any color from here. One more thing, if you do not like this color combination, you can go to more colors and you have now varieties of color. It is not limited to this much of varieties of color. You can go to this sections, and in this RGB, you can give the color code, the exact precise color. If you want, you can set that exact precise color by giving this color code. Isn't it interesting and fantastic? Right, so close it. And the next is MATLAB command window color. The error will be appeared as red. You can see here. You can make it blue, right? Here it shows blue color. Let's make it red again. Hyperlink, over here the hyperlink is presented. You can make it white. See here the hyperlink, black, whatever colors hyperlink you want to make, you make it from here, right? Warning text, it is orange. you can change it the way you want, right? So all this customization can be done. I do not want to apply this customization, so what I'll do, I'll just cancel it and we'll go to preferences again. How to set MATLAB color preferences, that we have understood. Now we'll go for the font preferences. For that you need to go to font, and here you can customize the fonts. In that you can go to this customize tab and you will have all the varieties of tabs. This is your profile. If you want to change the font style in profile, then you can set it from here. It's for command window. First I will do it for editor. The rest of the thing is same for all, right? So you go to editor, you can use desktop code, desktop text. It will take by default font size and font style. But if you want to customize this, just click on customize and here you have varieties of font. Let's change any font to lemon. So this is how the font looks like. You can set lemon, plain, bold, italic, whatever you want. You can set the font size from here, right, and apply it. So here you can see in editor we have changed the font to lemon. Let's make it Cambria again. I like Cambria especially, so I use that font only. In current folder, so this is our current folder. So in current folder, this is desktop text. If you want to customize it, just select and let's make it lemon again. Apply. So here you can see it's lemon, right? Let's make it default again. So in workspace, in variable, in command window, wherever you want to change the font, you can set that font property from here. The color of font that can be set from this color preferences. For your code, for string, for syntax, the color can be set from this color preferences, and the other font parameters like font style and font size can be set from here. Let me just quickly change the font size so that you can have idea about this. It's 36. Many times it happens that you want to sit back, relaxing, and then work on your code. In that condition, if the font size is larger, that would help a lot. So this is how you can set color and font preferences for MATLAB.
In today's session, we are going to learn basic arithmetic operations that can be done in MATLAB. There are basic 4 type of arithmetic operation that we are well aware with. Plus, minus, that means addition, subtraction, multiplication and division. So let me show you that how you can do all these 4 operation using different variables in MATLAB. And then we are going to implement some of the more complex equations in MATLAB programming. So let's start with simple programming. So initially let me take a variable a which is equal to 8. So as I have entered, the value of a is stored in the matrix, and now we are going to implement another. Let's call it b. b is equal to 18. So value of b is also stored in form of matrix. Now we are going to do addition. So let's take c is equal to a plus b. Enter, and the answer c is equal to 26, right? So MATLAB understands that c is equal to a plus b. The value of a that has already been defined in Workspace, b that also been defined and available in Workspace. So from these 2 values, MATLAB can calculate c. But now instead of capital A plus b, if I write this thing, c is equal to a plus b, then let's check what happens. It says undefined function a. So you need to keep in mind that MATLAB programming is case sensitive. There is difference between capital A and small a. So keep this thing in mind and then do it by yourself. Now just use this command CLC and clear command window. Now we are going to do subtraction. D is equal to A minus B. It shows the answer 8 minus 18. If we do division, let's take E is equal to A divided by B. It shows 0.44. So this is how we can do division. Now let's go for multiplication. F is equal to A into B, and it shows 144. So all these simple fundamental mathematical operations, this is how we can do in MATLAB. But now what we are going to do, this is very simple and fundamental, but I have started this MATLAB series keeping in mind that you have no touch of this thing, MATLAB, or no touch of any programming, right? So doing all these things from very basics. So stay connected to this channel as well as this video to learn MATLAB in detail. Use this CLC command to clear command window, right? Okay, so now we are going to implement some of the complex formulas or equation, a step ahead than simple mathematical operations. Let me show you that if I want to implement this equation, h is equal to 4 square minus 1 divided by under root 5. So this is the equation, or this is the formula which I want to implement in MATLAB. So keep this thing in mind, 4 square minus 1 divided by under root 5. So let me show you how we can implement this thing, right? Okay. So the formula was 4 square minus 1 divided by under root 5. So first of all we will implement h is equal to, we'll write 4 square, 4 raised to 2 minus 1. We'll place this thing into bracket, 4 square minus 1, this thing also in a bracket, divided by under root 5. Now when you want to implement under root, there is a special syntax for that, and that is SQRT. SQRT, square root of, so here we want to implement square root of 5. So square root of 5 and press enter. The answer is 6.7087. 4 square is 16 minus 1 is 15, and 15 divided by under root 5. Let's calculate that thing. Is the answer is correct or not? Under root 5 is 2.23. 15 divided by 2.23 gives us 6.72, and our answer is 6.708. So it's almost 6.1. So this minor difference, it's because of the number of digit we have taken, that accuracy that we have taken in calculator, that is different than this MATLAB. So the answer is correct. So this is the manner that how you can write equations and formulas, how to implement these formulas in the form of equation. For that you need to remember the law of body mass. So this is how you can implement these equations. So h is equal to 4 square minus 1 whole under root 5. Now we are going to implement something else. Let's assume a little bit more complex equation. I instead of I and j, what we are going to use? K. Because I and j is used for complex number in MATLAB. So whenever you want to implement the variable I or j, you should not use I and j. Instead you use any other variable. You can use a1, a2, a3, any of the combinational number you can use. But avoid using I and j. So now we are going to write equation for k. K is equal to under root 4 square plus 2 into bracket 3 square plus under root 9. So this is I want to implement whole under root 4 square plus 2 into bracket 3 square plus under root 9 bracket over. This is what I want to implement. Now let's try to implement this thing. The simplest way is place bracket as much as you can, right? So we'll start with k. K is equal to, now what we want everything under root. The whole equation we want under root. So what we'll write SQRT, square root of everything, and in that square root of everything we want to implement 4 square. So it is 4 square, that's over, plus 2 into the bracket 3 square, so 3 raised to 2 plus, you should use this bracket 3 raised to 2 plus SQRT square root of 9, bracket over, this bracket over, and finally this bracket over. And once you write the answer, k is equal to 6.3246. Now what you need to do is you need to calculate this in calculator and verify with this k whether it is correct or not, and then write the answer in comment section below. If it is correct, then say yes, and if it is not correct, then say no. So I am waiting for your response. Now we are going for a little bit complex one, and we will implement it as L. So let's take this equation. L is equal to 3 multiplied by under root 2 plus 1 divided by into bracket under root 4 minus 2 square raised to 2. So this is what we want to implement as L. See, why we are implementing this complex equations or this little bit trickier equations right now in this video? Because in upcoming videos, when we are going to implement big program or a script program, at that time this knowledge is required in that video. Or whenever you are programming in script or you are making long programs, at that time this fundamental knowledge is useful. So after watching this video, it is advisable for you to have some hands-on practice in MATLAB. And to have hands-on practice on MATLAB, I will provide you several equations to do this hands-on practice. So let's try to implement this thing. Until that time, let's keep this equation into your mind. Now we are going to implement this thing. L is equal to 3 multiply by, we will use 2 bracket. This first bracket is for denominator and numerator, and the second is for individual numerator. So we'll start writing SQRT square root of 2 plus 1. So the numerator is over. Now I'll go for denominator, divided by, we'll start equation for denominator 2, SQRT square root of 4 plus 2 bracket over and raised to 2 square of the new denominator and bracket over and press enter. So this is how you can calculate L. So This is the simple arithmetic logics, how you can implement this arithmetic equations into MATLAB. In next video, we are going to study exponential and logarithmic functions, how we can implement this exponential and logarithmic functions into MATLAB. But before that, there is few exercise for you. I am displaying these equations to you. You need to implement those equations into MATLAB and then you need to tell me what is the answer. So first equation is x is equal to under root 4 square plus 9 plus under root 3 divided by 3 plus 8 square. Y is equal to 3 square plus 4 plus under root 15 divided by 9 square plus 3 by under root 2. So x and y, you need to calculate these two things, implement in MATLAB, find what is the answer and type in comment section below. But I would like to request you that if you like my efforts, if you like my videos, then please like, share and subscribe to this channel. In this video, we are going to learn basic script writing techniques and we will try to implement a small script, and with this we will understand basic commands and functions in MATLAB. So let's get started. So to start a script, we'll go here and click new script. So a new script is opened, and what I want to implement, for example, I want to define a variable xl and the equation for that variable xl is equal to 2 pi fl. Those who are with electrical background and those who have studied basics in basics of inductor, they are well aware with this. This is the equation of inductive reactance. Let me write this equation. The equation is,
Hey there, I have provided this complete MATLAB course for free and I hope it is very helpful and valuable for you. After learning from this course or after completing this course, if you find it valuable for you and if you want to appreciate my efforts, please do consider donating. Your support will help me invest more time and resources into making even better tutorials and provide valuable learning experience for you. You can find the donation link in description box below. So thank you so much for your support.
xl is equal to 2 pi f and l. So what I want to do is, I want to write a small script for this equation. So now let's start. So the equation is xl is equal to 2 into pi. If you write pi, MATLAB directly understand it as pi. You do not need to write 3.14. And then we'll write x multiply by l. So this is the first line. Now let me tell you that when you run this MATLAB script file, how MATLAB starts understanding the script file. It will start with line 1 column 1. So this is line 1 column 1. So it will start solving this equation with this xl is equal to 2 pi f into l. But see, 2 and pi is known to variable because these are 2 digits and pi is already pre-installed in MATLAB. So pi is a basic by default function. Now x and l, these two is unknown variable for MATLAB. So you need to keep in mind whenever you are preparing your script file in MATLAB that this thing should be clear, that whenever, see this is on first line, right? For example, it is in third line. Your script file is going to solve any of the equation or running any of the line. It should be aware with all the variables in that line. But here x and l is unknown. So what we need to do is, when MATLAB reaches line number 3, it should be aware that what is X and what is L. So from this it is clear that we need to define X and L before line number 3. So what I am doing, I am defining X is equal to 50, right? So we have defined X is equal to 50, and let's define L is equal to 0.002. So what happens, we have defined X, we have defined L. So now when MATLAB starts running this script file, it will store X as 50. So first it will store 50 in Workspace. When it comes to line number 2, L is equal to 0.002, so it stores value of L. And when it reaches line number 3, it's understand that XL is equal to 2 pi XL. So from this it will use value of X and L. Whatever we have value assigned to this X and L previously into this script file, it will take values from that, and then it will calculate XL. So what we'll do, we'll just run this small 3-line script and let's see what will happen. But see, initially we have not saved this file, right? So without saving, when you press run, it will show save. See, save this. So what we'll do, we'll write it as simple script, and we'll store this thing in MATLAB work, right? So we'll store it here, MATLAB work. Let's save. So now over here in editor you can see the path, but whenever you change the path, it will ask to add to path. So we need to just click on add to path, and then it runs the script. We have the answer, XL is equal to 0.6283. What I was showing you is, this section will show you the path of your script file, right? This section will show you the path of your script file. Why I am going slow in this video? Because this is very basic and initial section of the programming of MATLAB. So it is very important to understand each and every aspects of this programming syntax, so that in future you can make programs by your own, right? Now let me show you a few more things in this script file. See, if you have defined X and L before this thing, before this line, then that's fine. But by mistake, if we are defining it below this, then what will happen? Let's run and check it. Let's clear this thing, clear all the variables from the workspace. So clear all is the command to clear all the variables from the workspace, and now we will run. So MATLAB shows that undefined function or variable X is written. So this X is undefined. Why it is undefined? Because it starts with line 1. There is nothing in line 1, so it will come to line 2. So XL is equal to 2 pi. So up to pi, everything is known to MATLAB. But when it comes to X, it will check, and it will go and check its workspace. But there is nothing mentioned like X in its workspace. So what MATLAB will understand? It is undefined function or variable, right? So that is why MATLAB is asking that there is some error. It is undefined function or variable X, right? In that, MATLAB asks that error in this simple script. So it is the name of our script, line 2. So there is error in simple script line 2. So there is some error in line 2, right? So this is how MATLAB asks you that there is something wrong with that syntax. Please try to correct it. So what we'll do, we'll cut this X, paste it over here. L still below, right? L is still below that line. Again we'll run this thing, and now let's see. Undefined function or variable L. Up to X, everything is fine. It will start with line 1, x is ready, xl2 is okay, pi is okay. Now x is also okay because it is defined before line number 2. But L is not okay because we have not defined L before it. So what we will do, we will define L, run it, and now the result is here in front of you. So this thing you need to make it very much clear that whatever formula you are writing or whatever equations you are implementing, you need to make it sure that all the variables in that equation, it should be appear before that equation. Now let me show you one or two more things in this script file. For example, for future use, if you want to mention something that this x is the frequency, the L is inductance, so that you can mention using this percentage sign. Place percentage sign and write whatever you want to mention it. For example, we are mentioning it, its frequency, so we are mentioning unit. The unit is hertz, right? So this percentage is represents note. Whatever data we are entering after this percentage sign, this script will understand this as a note, and it will not add this thing as a part of program. When you run this program, it will not be the part of that program. It is just for understanding purpose who write the script, right? Here for example, we are writing its L, so its unit is millihenry or henry. So we are representing as H, and XL, that is reactance, we call it in ohm. So we will write ohm, right? So we have provided this percentage sign, right? And now let's see if we run this thing, everything functions well. It's not going to be any issue and any problem for us, right? But now let me tell you that what if by chance we remove this thing, right? So for that, clear everything from the workspace, and now let's run again. So when we run this again, it will show error. Where is this error? In this script file, line number 1, column 22. So this is the script file. It's the line number 1, 2, 3 up to this is column number 22. So the error is in line 1, column 22. Up to this much specification MATLAB gives to us. So it's very easy if you understand. If you learn how to read the errors expression in MATLAB, then it will be very much easier for you to understand all of these things and troubleshoot your scripts in MATLAB. So now once again you are rectifying the error and solving it. Let's run it again, and the things is ready, right? Now one more thing I'd like to show you, that every time when we run this script file, it shows x is equal to 50, L is equal to 0.002, and then XL. But what do we want? Where we are interested? We are interested in only knowing XL, because these two things we are telling them, right? So we do not want to see these on this command window. So for that, what we will do, we'll again clear this thing. For that, you can place over here a semicolon. The meaning of this semicolon is, on whichever line you are using this semicolon, this means that you do not want to see the result of this line on command window. It will calculate, it will process all the data, but it will not show the output on command window. Let's check this thing, run this thing. See, this is simple script, our file name, and the result is direct XL. Variable X and L is stored in the workspace. Over here you can see X and L is available, but it is not presented over here in command window. When you use this semicolon, it does not show result in output. So this is the basics of programming, right? This is how you can prepare a basic simple script in MATLAB. There is a quick short question for you. The question is on the display. Read the question and try to write answer into the comment section below.
Hey, if you thinking to write long MATLAB scripts and you are doing some type of research, if you are doing some type of analysis where you need to change multiple parameters frequently, then there is one small important thing, a thing called user input. Once you run the screen, you need to give input in command window, and using that input, all the analysis or calculation has been done. So in this video, we are going to learn how to give a user input once you run the script. So without wasting time, let's get started. We are going to learn how to give user input. So first of all, let me show you this simple script file. This is the script file that we have understood in our previous videos, where we have learned how to give a specific output text to our calculated variables. So let me run the script. So this is how it gives output. This is the script file for calculation of circle, right? Various parameters. Now here we are calculating all these four parameters, but to calculate these four parameters, this is our user defined parameters, radius and height. So what we'll do, instead of defining radius and height initially in the script, we'll make such change that it will ask once we run the script, and whatever value we'll give to r and h, it will run accordingly. So now instead of this r, we'll write, so this is how using this input command we can give input. So using first line, we'll clear the command window, and using second line, clear all, will clear all the data in workspace. This is the input command. This is the syntax to write input command. You need to write into bracket, into inverted comma, whatever you have written in between these two inverted commas, it will be printed as it is. So now let us just run the script. So see, it's asking for radius. Let me give 10, enter. Now it's asking for height. Let me give 5, enter. And there we go. This is our calculation. After this calculation, let me run it again. Just remember, it's 20, 62, 314. Run it again. Now let's give it 2, enter, 4. And the calculation is like this. So this is how you can give a user defined input in your script file. Now in this script file, let me run it again. Instead of numerical, if you give any string like this, mj, and enter, then it will define as inappropriate input. For example, now if you want to give string input, then let us take a small example for that. Now see, here I have defined input, what you want to do, and then after comma I'll specify s, that means string. Let's run it again. I'll add few space over here, and then we'll run it again. So it's asking for radius, I'll give it 5, height 2, what you want to do, calculation, and there we go. So if you specify it like this for string, it will take this as a string, otherwise it will show some error. So if you want to learn anything more on MATLAB, you can write that thing in comment section below. That's all from this video.
Hey, if you want to write MATLAB function for short time, then there is a one method. But if you want to use that MATLAB function for longer duration, then there is another method. Here in this video, I am going to share three different ways to write MATLAB function. And if you want to know how to write MATLAB function, just watch this video till the end. We are going to explore the same thing in MATLAB. So let's quickly get started.
Whenever you are going to write MATLAB function, just remember first word must be function. So let's write that thing. So after this function, let's say for example, I want to write a function to plot a sine wave of particular amplitude and frequency. I want to plot sine wave with some amplitude and frequency. So I'll write. So this is what I want to name this function, sine plot. So f is equal to sine plot of a comma b, bracket over. The a and b are two variables. A will be representing the amplitude of signal and b will be representing the frequency. So now let's write the function. In that I would be requiring t, and the equation of my function f is equal to, so it is 2 pi f into t. F represents frequency, so instead of f I am writing b. So 2 pi bt. Till here I have written the function. Now in this function I want to inbuilt the plot command. So I'll just do plot. On x-axis I want time, so t, and on y-axis I want to plot this function f. Right, so plot t comma f, and then we will end the function. You must remember that the script, the function must start with function word and must end with the end word. And now let's save this thing. So click it, save it. It popped up. I want to save it in this folder, and the name is automatically sine plot. So save it. So we have saved this sine function, and now let's just try to implement this thing. So now let's just write sine plot 1, the amplitude is 1 and the frequency is 2, and let's run. And there we go, the function is ready. Suppose instead of frequency 2, if you are in US and you want to plot the frequency of supply 60 and maybe the voltage is around 110, so there we go, it's 110 and 60 hertz frequency. If you are in India, the frequency is 50 hertz and supply is around 220 volt. So it's like this, and there we go, it's the waveform of voltage.
Hey there, I am thinking to provide two things. First, a free certification MATLAB course, and a second, in depth structured course with exclusive content, exercise, and support which goes beyond what it's available here, and that is paid MATLAB course. So please let me know by commenting or filling out the interest form in description box below whether you are interested in free certification course or in paid course. Thank you so much.
So over here, instead of this sine plot, you can even name it as voltage plot or anything else like that, whatever you prefer. Now just imagine, what if we have not saved this function? Let me delete this function from that directory. This is the sine plot. I'm deleting it. I've deleted it. Close it. And now let's just try to plot the same thing. Undefined function or variable sine plot. Now again, if we save this thing, save as sine plot in the same folder, and now let's again try to run the same thing, and there we go. So this is how you can create whatever function you want to implement in MATLAB. Now let us check how keenly you have watched this video till now and how much you learned. There is a quick question for you and you must answer that question in comments below. And your question is this: what must be the first word in MATLAB function file? Your options are name of function, type of function, begin, end. These are the options. Just think and try to answer in comments below. Now we'll see another way of writing the function in MATLAB. Over here in the script file, whatever function we have written, we have given some specific name to this function. This function can be used as long as you have kept that file in your MATLAB folder. Now we are going to implement another function that is basically an anonymous function. You do not give any specific name to that function and you just write that function for your same day calculations or your selected several calculations. So let us write some anonymous function. For example, f1 is equal to @ into bracket a. So with this @ into bracket a, we are defining that the variable in this function is a. And now we'll write the function. Let's say a square plus 5. So a square plus 5, it's our function. So let's enter. So it gives function handle with value. And now we'll go for a different calculation for this function. For example, f of 3. Oh my god, the name of a function is f1. Sorry. So f1 of 3 is 14. For example, if we take another value, f1 of 4, so it's 21. So here you can see that our function f1 is stored like this. So this is another way to write the functions. Even you can write multiple functions and do your calculation as per your requirement. For example, I'm writing f2. So this is my function f2. And now if I want to find f2 of 3, that gives me 18. For example, if I want to find c is equal to f1 of 3 plus f2 of 3, and that gives me 32. So using this type of function, when you have to do short and small calculations, you can write the functions like this. Now another way to write this type of function is inline function. For that, let's clear this thing. So let's go for inline function. In this case, you need to write everything in line. For example, our function is f1 is equal to inline, and our function is a square plus 5 inverted comma. So this is our inline function f1 of a. Now you can write f1 of 3 is 14, f1 of 4, it's 21. So this is another way to write inline functions. When you are doing multiple calculations, you can use this type of inline functions too to serve your purpose. So guys, till now, if you have enjoyed this video, do not forget to hit the like button and subscribe this channel if you wish to subscribe. So these were the 3 different methods to write MATLAB function, and you have seen all these 3 methods. Just write in comments below which method you would prefer to write MATLAB functions. The question is, what is for loop? So basically it is a loop which is used to repeatedly execute a specific block of code for known numbers of time. This is the for loop. Let me give you an example. Just imagine there are 60 students in a class and you need to find the less attendance students from the class. So for that, You know that there are 60 students, so for 60 times you need to run this loop with your some specific logic, right? So in that case you can use the for loop. So the basically when the numbers of repetition is clear to us, we use for loop. What if the numbers of repetition is not clear to us? For that time we use while loop or some other loops. If you want to learn while loop and some another loop in MATLAB, we are going to explain those things in our upcoming videos. In the syntax of for loop, the first word is for. Then we are defining a variable which is nothing but the length of for loop. In that, we generally take I as a variable, and over here you can see A gem S gem B. A represents the initial value, B represents the final value, whereas S represents the step size. Then after a statement of logic, and then finally end. So this is the syntax of for loop. Let me elaborate these things for you. So we'll write for loop. Here I is the variable, where 0 is the initial value, 10 is the final value. So if you want to approach from 0 to 10, there are 9 steps, right? But what we are defining in our for loop, that the step size is 2. That means our for loop will jump from 0 to 2, 2 to 4, 4 to 6, 6 to 8, and then 10. So this is what the step size means. Now we'll go for the statement. Here our statement is m is equal to 2i plus 3. So for every value of I, it will calculate m and then end. So this is how we are going to write syntax of for loop. Now let us write this code in MATLAB and understand what's happening inside the code line by line. So here our code is ready. And now let's run, and over here you can see the different values of m. So for each value of I, it calculates different value of m. Now let us understand what is happening inside the code. So when we run the code, it will start reading the code from the first line, first letter. So when the first three letter is 4, it understands that we are going to implement for loop. Then it will go for the variable. It will understands the initial value, final value, and step size. And then it will move for the statement. So when it reaches to the statement, it will read that 2 into I plus 1. So initial value of I is 0. So 2 into 0 is 0 plus 1. So ultimately the value of m is 1, and it represents m is equal to 1. Then again it will go back. Now this time it will have a step size of 2. So instead of 0, there will be increment of 2, and it will jump to 2. It will come down. The value of I is 2 now. So 2 into 2 is 4 plus 1 5. So the m is 5, and this will keeps on moving until it reaches 10. When it reaches 10, it still satisfies the condition, and then it will come down. 10 into 2, 20 plus 1 21. So we have the value of m as 21, and again it will go up. When this time it will go up, it will again check the condition whether the value of I is within the band limit. In this condition, the value of I will be 12 because we have given the step size of 2. So the previous one was 10, so now it will be 12, and it will see it is not in the range. The initial value is 0, the final value is 10, so it is out of the range, out of the given range. So it will directly jump to the end section of the loop. And this is how this for loop works. Now we'll go for nested for loop. That means a for loop inside a for loop.
So for that, let us take two variables. Let's call one as m, and we'll go for 1 gem 5, so from 1 to 5, and another variable we'll name it as n, and let's say we'll go for 1 to 3. So first loop will be having variable I, and which starts with 1, and the first loop we want to go for the length of m. So here we'll write the command length of n, and then again there is a for loop because we want to create a matrix of m cross n, right? So we are writing the another loop, and the variable is j, which is equal to 1 gem length of n, right? And now we'll write our logic. For example, the variable name, the matrix variable name, I want to name it as a, and then we'll write I comma j. Why I comma j, that I'll tell you when I explain this thing. And then my logic is m plus n, so m of I plus n of j. That's it, and I will end the first loop, the and another loop. Now I'll simply run, and here you can see this is the final result of my A matrix, which is m cross n, m 1 to 5, so 1 2 3 4 5, 5 rows and 3 columns. So 5 rows by 3 columns matrix is ready using nested for loop. Now let us understand the line by line command of this nested loop. So when we run the code, it will start with line number 1. So here the line is m is equal to 1 gem 5. So it will print m from 1 to 5. The next line is n is 1 gem 3. That means it represents n is equal to 1 to 3. Now here it will jump into the loop number 1, where I is equal to 1 gem length of m. Length of m is 1 to 5, right? So initial value of I is 1. Remember, initial value of I is 1. Then it will jump to line number 4. It will again a for loop. J is equal to 1 gem length of n. Length of n is 1 gem 3. So initial value of j is 1. Now it's jump to line number 5. A is equal to I comma j. I is 1, j is 1, so a of 1 comma 1. So a will become a matrix and 1 comma 1. That means the element of that matrix is 1 comma 1, which is equal to m of I plus n of j. So I m of 1 is 1 plus n of 1 is 1. So 1 plus 1 is 2. So a is equal to 2. From line number 5 again it will jump to line number 4. Now the value of j is 2. I is still 1. Remember, I is still 1, but the value of j is 2. So a of 1 comma 2. So now the element number 2, row number 1, column number 2, m of I is 1, n of j is 2. So the first element of m is 1 and the second element of n is 2. Over here you can see the second element of n is 2. So 2 plus 1 becomes 3. So over here the value of a is 3 now. Again it will jump to line number 4. How many times it will jump to line number 4? It will jump to line number 4 equal to the length of n. The length of n is 3, so it will jump to j for 3 times, and it is the third time. So for that j is 3 now. So a is 1 comma 3, which is equal to m of I is 1, n of j is 3, so n of 3 is 3. So
M is 1, N is 3, 3 plus 1, 4. So here you can see 4. So at the end of J loop, we got all the 3 columns. Now it is the end of loop number J, which is inside the loop number I, and then again it will jump to line number 3. Over here I will have the increment of 1. Now when I has increment of 1, then I becomes 2, it will jump to line number 4, all the process will repeat again. But when it comes to line number 5, A is 2 comma 1. So here the value of I is 2 and J is 1. And you can see we are having this matrix. Like earlier, again it will rotate J loop for 3 times and it will jump back to line number 3. Again it will have an increment of 1 and then jump to line number 4. So this process will keeps on continue until the final matrix is being prepared. So here we have the final matrix. So this is how using nested for loop you can create this type of matrix. What is while loop? Basically, a while loop is used to repeat a specific set of program until a given condition is met. If the numbers of repetition is not clear to us, then it is best to use a while loop. Or if the numbers of repetition is clear to us, then we can go for the for loop. For example, just imagine that you are having a robot and you want to run that robot in forward direction for 100-meter, right? So you can program your robot like this, or you can give condition like this: while your robot reaches 100-meter, it will walk in forward direction. So these are the different logical conditions where you can fit the while loop, where you can use while loop at its best. Now let us understand the syntax of while loop. In while loop, the very first word we use it is while, and the followed by statement is a logical condition. Then there is a statement, and finally the last thing is end of loop. Let me give you an example where x is equal to 0 while x is less than 10. The initial value of x is 0 and it will go up to 10. So these are the different sequence that our x is going to follow. The statement is like this: x is equal to x plus 1. And finally, there is end of the statement. Here there are two important things that you need to be careful of. First thing is, whenever you are writing any logical variable, then you must define that variable before you write while. So before this line, you must define the value of that variable. Otherwise, what will happen if there is, when you have not defined this variable and you are placing the variable with some logical expression, then without any specific defined value of x, MATLAB will show error. I will just show you this thing while we implement this program. So this is the first very important condition to be followed. The second important condition is there has to be appropriate either increment or decrement in variable. Increment or decrement depends on your logical expression and the value of your x. Because you are not providing any increment or decrement in the value of x, then this while loop will become infinite loop, right? It will not end by its own. Likewise, we have studied in for loop, right? While loop has not specific numbers of repetition. It has infinite numbers of repetition if you are not providing appropriate increment or decrement to x. In this example, we are providing increment of 1 to the previous value of x. So gradually in every cycle, value of x increases, and once it reaches 10, right, it does not fulfill the condition. 10 is not less than 10, so it will directly jump to the end of the loop, right? So this is how we should write while loop. and these are the two conditions that you make sure it should be followed. Now let's jump to the MATLAB and implement this code and see what if we are not following these two conditions.
Hey there, I have provided this complete MATLAB course for free and I hope it is very helpful and valuable for you. After learning from this course or after completing this course, if you find it valuable for you and if you want to appreciate my efforts, please do consider donating. Your support will help me invest more time and resources into making even better tutorials and provide valuable learning experience for you. You can find the donation link in description box below. So thank you so much for your support.
Okay, so the program is ready, right? We'll run this program and see the output of the program, and then we'll check what if we are not following any of the previous two mentioned condition, and then we'll see what happens into the MATLAB. So first of all, let's run the program, and you can see that the value of x is presented. Initially it was 0 and then finally it is 10. So the program is running appropriately. Now what we'll do, we'll comment it, and we have cleared the variable from the workspace, and now let's run. So when we run the code, you can see there is undefined function or variable x, because how MATLAB functions, you need to understand this thing, how MATLAB functions. It run the code line by line. So when it reaches line 2, we are giving a logical expression while x is less than 10. So whenever you are expressing that when x is less than 10, then there must be a defined value of x. When you are not defining x, how good MATLAB understands that what is the value of x, right? So it is very simple and fundamental thing, right? But because this type of video I'm making for the beginners, so it is important to go through all the small details in the program. Now here, instead of this mathematical statement, let us write something else, like m is equal to 2x plus 1, right? And we'll comment it. So what we are doing, we are not providing any increment or decrement to x, right? And just run this loop, and you can see the program is still running. It is continuously, you can see in this corner, right? So this loop is continuously going on. It has become infinite loop. It is not at all going to stop any moment, right? So now let me pause this thing, right? So if you are not defining any incremental change or any decremental change in the value of x, then this loop going to be the infinite loop, right? Now let us do it again. This time we are defining increment in x, and let's run the loop. So here you can see x is 10, and we have got the different values of m, right? So this is what the importance of defining x previously and increment in x. Before we jump next, I would like to ask you a quick question. Your question is, what are the two important conditions of while loop that we have discussed in this video? So let us check really you have learned anything from this video or not. So write the answer of this question in comments below. And yeah, one more thing. Hit like and subscribe to this channel if you are really enjoying this video. So now let's get back to the video. Now we'll comment it and we'll write another program, and in that program we'll understand line by line what is happening in while loop. In second example, we'll go a little bit more realistic. We'll calculate the value of any factorial, right? Let's say 5 factorial or 7 factorial, right? So we'll calculate factorial using while loop. So for that, let us write the program. So here our program is ready. Now let us run the program and then we'll understand how this program functions line by line. So we'll enter the value. Let's say we want to find the factorial of 5. So let's enter 5 and that is 120. Instead of every time clearing the workspace, you can directly write here. So all the previous value of x been cleared. And now let us run this program. Let's say factorial of 8, 40320. So now let us understand the program line by line. CLC clears the command window. Clear all clears all the variables stored in workspace. The name is equal to input of enter value. It is used to take input from the user. Then we are defining I, which is basically equal to the user defined input m. Then the initial value of x is equal to 1. Then it will start the loop while I greater than 1. The initial value of m is given as 8. So here I is equal to 8, which is definitely greater than 1. So it will jump to the line number 14. X is initially 1. So 1 into 8 gives us 8. And here it shows x is equal to 8. Then I is equal to 8 minus 1, 7. So here we are defining a definite decrement. The value of I7 will again jump back to the line number 13 and it will does the process. It will keep on moving until we reach where I is equal to 1 and then finally I is equal to 1. So when I is equal to 1, it will again jump back to line number 13 where it will check the condition where 1 is greater than 1. It is no way greater than 1. So the statement is false and it will directly terminate this while loop and jump to the end of the loop. And then finally whatever the value of x we have, it displays at the end. So this is how the line by line process of while loop happens. What is if loop? Basically, if loop is a conditional statement that if the condition is true, it performs one function or else it performs another function. So this is the simplest form to understand if loop. Now let us understand the syntax of if loop. First you need to write if and then your logical condition. Then you will write the statement or the function which you want to implement if the condition is true. And then finally end. So this is how you write simple if statement. Now let me show you the flow chart of if statement. Here first we initialize, then we go for the condition whether it is true or false. If the condition is true, it performs a statement or function and then it will end the program. If the condition is not true or condition is false, it will directly end the program. It is the simplest form of if loop. Here you can add one more conditional. Here you can add another statement or another function if the condition is false. Let us check that syntax. Now here we'll see if the logical condition is true, it performs this statement or function. But if it is not true, then it performs some another statement or task. And for that we need to write else. So else and then statement or function. And then you need to end the program. Here one tricky thing that you need to remember is in else condition you should not give any logical condition. You need to give only one logical condition in if statement. If the logic is true, this will happen, else in all other condition this will happen. So remember that many times many students make this mistake that you write one logical condition in if and you write another logical condition in else. This is not the way. If this is true, this will happen, else in all other condition, this will happen. For example, if you need to give multiple logics, right, multiple logical statement in your program, then you need to go for nested if loop, or we can call it as if else if loop. Let's understand that thing. You need to write if your logical condition, then followed by the statement, and then you need to write else if, and here you need to provide the logical condition. So this is first logical condition. If this condition is not true, then it will check this condition. Then if it is true, then it will go for this statement, and if this condition is not true, then it will go for else, and then finally the program will end. But remember, whenever you are writing else, you should not provide any logical condition in that line. Let me show you the flowchart for this if loop. Here one more thing I would like to tell you. Here we have used only one else if condition, but if you wish, you can use 5 conditions, 10 conditions, n numbers of else if conditions you can use in sequence. Now let us check the flowchart for that n conditions of else if loop. This is the flowchart. We initialize, then it will check condition 1. If the condition is true, then it will run statement 1 or function 1, and then it will end. But if the condition 1 is not true, then it will go for condition number 2. The same thing happens for condition number 2. If it is true, followed by this statement, it will end. And if it is not true, it will jump to the next condition. So you can go up to n condition, and in nth condition, if it is true, it will go for this statement or function, and then it will end. And if it is not true, it can directly end, or at that place too you can give any function or statement, right? So this is the flow chart of multiple if loop or nested if loop, or you can call it as if else if loop. Now we'll go for a simple program, and then we'll go for more complex program in this video. So stay tuned and stay connected. So now we are going to write the program. But for this program, I don't like this layout, so I'm going to change layout to big editor. So now here our program will be displayed and the command window. If you want to save your preferred layout, it is very simple. For example, this is my preferred layout, right? Then you have to set this layout, then go to layout, and then save layout. When you click on save layout, it will ask you to enter the name, give whatever name you want to give, and then press OK. Then you can see those names in this layout, and you can choose in between. So now we are going to write a program where we'll identify whether you are adult or not. So first I'll write complete program, and then I'll explain it to you line by line. So our program is ready. In line number 1, what we are doing, in line number 1, I am asking for the input from the user. Enter the current year. Then in line number 2, I am asking enter your birth year. So here user need to enter the year of their birth. And in D, I am calculating the difference between these two years. And then if the difference is greater than 18, if the condition is true, it will print as you are adult, else it will not show anything. So let us try this thing. Run. So it is asking for current year, so it's 2022, right? It's year of your birth. For example, you are born in 2001. So here you can see that it shows you are adult. Now let us run it again. 2022. Your year of birth is suppose 2015. The difference is 7. It does not show anything. So the program directly ends, but there is no else statement. As you can see on the display, if the condition is true, it performs one task, but if the condition is not true, it directly ends. So you can see it is directly ending. Now what we'll do, we'll provide else condition. What if this condition is not true? We want to display something else. So now we'll display something else. So if the condition is true, you are adult. But if the condition is not true, it will display you are not adult. So let's run this thing. 2022, it's the current year. Year of birth is 2015. And it shows you are not adult. Now on the display you can see the categorization of all the age groups, right? So for example, if you want to categorize, if you want to pick from the data that which age group you belong to, then how you will do it? It is very easy using if loop. So now we are going to implement this logic that we want to identify that you belong to which age group, right? So let us do it. So now we are going to modify this program as per our new need. So in that, the condition number 1 is for age ranges from 0 to 1 year, it is categorized as newborn or infant. So for that we'll write if d is greater than 0, but here it should be greater than 0 but less than 1. So you need to provide two conditions over here. So how you provide two conditions? If you write d greater than 0 comma d less than 1, this way it's not going to work. For that you need to provide one more thing. To provide two conditions you need to write and in between. D is greater than 0 and D is less than 1, and in that condition you are newborn. So you are newborn or infant. Else if, now we are giving second condition. The second condition is the age range is from 1 to 5. So D is greater than 1 and D is less than 5. Here if you want to consider exit 5 with this age group, then you have to write less than and equal to 5. And that age group is known as toddler. So this is our second condition. Likewise, we will write all other conditions. So let us quickly go through that thing. So here our program is ready. So now I'm going to clear the command window. So command window is clear now, and now we are going to implement this thing. So we'll run the command. So it's asking for current year. So it's 2022. Let's suppose say anybody who is born in 2019, right? So we are entering it is 2019, and it says the difference is 3 and it is toddler. So there is additional e over here, so we should remove it, and now we'll run it again, but it gives us the perfect answer. So let us do it again. Okay, so now let's run the program again. Current year is 2022, and now let's suppose somebody who is born in 1991, right? So according to the calculation, that person is adult now, and we should get the exact answer. And yes, our program says you are adult. So this is how you can use this if else if loop conditions, if else if statement conditions to check to run your programs. Now let us understand this program line by line. The first line asks for input, user defined input. The second line is also asking for user defined input. In first line we are asking for current year, in second line we are asking for the year of you born. The third line calculates the difference between you born and the current year, and then from fourth line our condition statements begins. It checks if d is 0 but less than 1, In our last program, the difference is 31. So 31 is definitely greater than 0, but it is not less than 1. So this condition is not true. So it will jump to line number 6. It will again check if d is greater than 1. Yes, it is true, but it should be less than or equal to 5. No, it is not true. So it will directly jump to line number 8. Again, it will check it is greater than 5 but not less than 13. So it will jump to line number 10. It is definitely greater than 13 but not less than 18. So it will jump again to line number 12 and it says else. If the previous all conditions are not true, then display this, and it is displaying that you are adult, right? So this is how you can use this if conditional statement to perform your various logics. Let me ask you a quick question. In else statement, whether you are required to give any logical statement or not, you need to think on it and write the answer in comments below.
Here in this video, we are going to discuss how you can plot 2D graphs in MATLAB. And not only that, but how to make that graph more attractive, visually look appropriate. That is also what we are going to learn in this video.
For that, we are going to use a script file. So I have already opened the script file, and now let's write the script for the plot command. So the script to plot a simple sinusoidal waveform, it's ready. Now let me explain the script briefly. Here I am defining a variable t, and that will become our horizontal axis. It will starts with 0, it will reach up to 2 pi or goes up to 2 pi, and the step size will be 0.1. This is how you can represent some variables. It is one of the technique. Now the next thing is a, which is the function of sine, right, and that has been represented over here. And then finally I have written plot x comma y. Whatever axis you want to put on horizontal, it will come first, and vertical axis will come next. So this is how you can plot a simple graph. I have put semicolon over here. The purpose of putting the semicolon over here is when you put semicolon at the end of any line, the output of this line will not be reflected in command section. So our command section will not get full with all the outputs which we do not want to see. So that is the purpose of this thing. So now we'll run the script and see. This is how we can get the simple sinusoidal waveform. Now we'll add some things to this and we'll make it more attractive and professional. So let's close this thing. Now I'm writing help plot. When you write help plot, this window gets open. Remember these 3 columns. The first column represents the color of your plot. Blue, green, red, whatever color from this section you can pick to plot your graph. This represents the marker. So if you want to add marker on your data point, you can choose any of this style to add your marker. And the last one represents the line, this style of the line. So in initial section, we are going to work on the style. So how we can use these things? Let me show you. First of all, let's change the color to red, and for that we'll do this thing. So just in comma add R, run the thing, and you can see our graph is red. But on every 0.1 step, see over here the step size is 0.1. So on every 0.1 we are having a one data point, right? So on that data point, if I want to add the marker, right, I can add marker of this different styles. For example, let me add a marker of triangle, right? So for that I'll just add this mark of less than and run. See, instead of solid line we have a triangle, right? On all the data points we have the triangle. But what if I want line and marker both. So for that, for example, we want to have a solid line. So just have this dash. See, we have a line, all the markers, and this is how a graph looks like.
Hey there, I have provided this complete MATLAB course for free and I hope it is very helpful and valuable for you. After learning from this course or after completing this course, if you find it valuable for you and if you want to appreciate my efforts, please do consider donating. Your support will help me invest more time and resources into making even better tutorials and provide valuable learning experience for you. You can find the donation link in description box below. So thank you so much for your support.
Now there are varieties of line you can use, right? Let me try anything else. To show you anything else, right, what I'll do, I'll just remove this marker so it looks appropriate, and we'll use double dash. Double dash is for dashed line, right? So we'll run this thing and see, you can have this dashed line. So using these commands, right, so using this you can add your flavored color or your flavored style to your plot. Now there is still something interesting is coming, so please wait. Now what we'll do, we have used this marker. Just remember this plot, right? This was the plot. Just remember, we are going to change the size of this marker. Yes, we'll change the size of this marker, and for that we'll write a command. So now we are going to change the size of the marker. Just run this thing. Can you observe any change in marker size? If still not, we'll further reduce it, and maybe now you will be able to notice this thing. So using this command you can change the size of marker. The same thing you can apply with the lines width. Now let me show you that thing. Initially we are keeping it to 5, and see the width of the line, it's 5. Now let's just reduce it up to appropriate level. So now this looks a little bit appropriate. Now let's add grid to this graph, and for that you need to just simply write grid on. See, this is how you can add grid to the plot. Now in this section we are going to add name to the axis and title to the graph. So let's begin with that, and for that you need to write a simple command, time, and y as amplitude. Time and amplitude. Now we will give a title to this graph.
Hey, before you move ahead, there is a quick short question for you. This is for your brain test. I am going to ask you a small question and you need to write the answer in comments below. The question is this: which of the following command is used to change the size of marker? Your options are this. You need to write the answer of this question in comment section below. I am asking this question just to give you a verification that whether really you have learned anything from this video or not. So everything is done, but do not forget to write the answer in comment section below.
Sine wave graph. Now if I want to change the size of these fonts, how can I change that? So let's do that thing. See, font size we have reduced it up to 8. so it looks a little bit smaller. So this size is enough for horizontal and vertical axis, but I want to increase the size of title. So let's do that thing. See, now suppose if I want to add legend to this graph, there is a simple command. This is how you can add legend to this plot. Now for example, if I want to add some additional text in this graph, let's see how we can do that thing.
Hey man, one more question is there to check whether you have learned anything from this video or not. Your question is this: which of the following command is used to name the horizontal axis? Your options are this. Do not forget to write the answer in comment section below. So now I am going and you carry on with the video.
So let's add some text to this graph. So this is how we can add text. Now we have given the location is 1 and 0.5. For example, if I want to write theta 90 over here, then x-axis is 1 and y-axis is 0. So I'll update this thing and run. So this is how you can make your simple plot into attractive plot. In next video, we are going to see how we can add multiple plot in one figure.
Hey man, if you are thinking to plot multiple graph in one figure like this, or multiple plot in one graph like this, then this is the right video for you. Here in this video, we are not only going to learn how to plot multiple graphs, but also how to make it more attractive using different functions. So without wasting time, let's quickly jump to the video.
In previous video, we have seen how to plot a simple graph. For that, you just need to write this much of thing. We'll remove this added things. So these 3 lines will give you a simple sinusoidal plot. Just run this thing and we can have this simple plot. So previously we have seen how to make this simple boring graph into an exciting graph like this. It seems more appropriate, it looks very nice, more professional. So if you want to learn that thing, then you can check out my previous video. The link of that video is provided in description box below and here in card. We will use the same script to plot multiple graph in one figure. And if you want to download this script file, you can join our Telegram group. There I will share this file and you can modify it as per your requirement and you can reuse it wherever you want to use. Up to end of this video, whatever changes we are going to make in this script file, you can download this script file from our Telegram group. So stay tuned to this video till the end. Now here in this graph, we have one sine function. Now what we'll do, we'll add one more plot into same graph. So two plot in one graph. So we will add one more waveform and that will be cosine function. So let's write script for that. And to do all these things, we are going to use this same script. We'll add these details into the script. So first of all, I'll write script to add one more function, to add one more variable to create a graph. Let's call it b. So b is equal to cos of t. So ultimately we are defining another variable b. This a variable we are using to plot a sinusoidal graph and we'll use this b variable to plot a cosine graph. Now this fourth line represents command to plot a sine graph. Now we'll write it again, plot t comma b. We are just writing it very simple basic plot command. And let's see what happens if we directly write this plot command. It's just showing me only cosine graph. It is not showing me the sine graph, right? So to have both this plot in one graph, we need to write some additional command. So let's close this thing and let me tell you that additional command is hold on. So we need to write it before we write any plot command. So here we'll write hold on. So what it will do, it will hold value of all the plot and represent all the plot in one graph. So let's implement this thing and run the circuit. So we have written the hold on and now let's run. Now you can see we are able to observe both this graph. But the thing is, this graph is simple and we have added these things to this graph. So now let's make this graph also a little bit attractive. So what we'll do, we'll just copy all these things, comma, and paste it. I want to make the color of this graph blue, so I'll represent this with blue and the rest of the thing will be same. So now you can see both this graph looks nice. Now I don't want this theta 90-degree text, right? So I will remove this text line and run it again. So now I have appropriate graph. So now the graph is looks appropriate, but this legend is showing only sine wave. So now I want to add legend of cos wave also. So for that what we'll do, over here we have written legend, but that is only for sine wave. So we'll add cos wave 2. So that's it and let's run it. So now we have legend of sine wave and cos wave both. But the thing is, over here my legend is overlapping my graph, which is not appropriate way. So what I'll do, I'll change the location of legend. I'll close this thing. I'll go in this legend command and write location best. So it will place this legend at the best possible location. Let's run this thing. See, the legend has been shifted to such a location where legend is also clearly visible and full graph is also clearly visible. There are various locations of this legend you can set. This area is known as east area, it's west area, south area, north area, southeast, and likewise east north, west north, and southwest. So you can place this legend anywhere you want to place. Let's place it in east area. So we'll close it. Just remove this best and write east and see it shifted over here. So likewise, as per your requirement, you can set the location of this legend wherever you want. So if you are confused about where to locate this legend, then let this hassleful work be done by MATLAB. And for that, just remove this east, write best, and run. So MATLAB will automatically place it on the best possible location. So this is how you can have a multiple plot in single graph. Now the next thing is, if you want to plot multiple graph in single figure. Now let's understand the difference between these two. Multiple plot in one graph means here there is only one graph represented and these are two plots in one graph. But this image is one figure. So if you want to add multiple graph in one figure, that means one graph over here and the another graph on another location, that is known as multiple graph in one figure. if you want to plot multiple graph in one figure, then you need to use some another command. So in this section we are going to explore that another command. So let's explore that thing. Close this. So now what we'll do, now we want to try another thing. So for that we do not require this hold on command, right? So what we'll do, we'll just make it a comment, so it will not be counted as a part of our script. So to plot multiple graph in one figure, we should use subplot command. The command is subplot. Now what this subplot does, actually it creates m cross n matrix of a figure. Let me show you an example to exactly understand what this subplot tries to explain. So in this example you will be able to understand the subplot will create a matrix of R cross C, row cross column. So the intersection point will be one location for each figure. So for example, numbers of rows are 2 and numbers of column are 3. So the matrix will become 2, 3. And in that matrix you can place 6 different graphs in one figure. The numbers of these figures are like this: 1, 2, 3, 4, 5 and 6. So now when we see the syntax of subplot, it will look like this. So subplot 2, 3, that represents a matrix of 2 row and 3 column. That means in one figure you can place 6 images. And when you write 1, that means whatever plot command you are going to write after this plot, that graph will be plotted in location number 1. So to place another image on location number 2, again write plot and change this 1 to 2. So it will place new graph in location number 2. So now let's implement this thing in MATLAB and understand it a little bit better. So here we are going to write subplot 1, 2, location 1. Let's run this thing. See, we have created two graphs, right? But second graph we are not able to see. We are able to see only one graph. Why it is like this? It is so simple, because the location of second graph we have not even specified. So we need to specify the location for each and every plot. Then only all the plots will be able to visible. So what we'll do, we'll copy this thing, write it after this over here, location number 2. Let's run it, and now you will be able to see this thing. So can you see both the graphs are available now? There are few changes in both the graph, and that we are going to see. But just imagine, I'll close this thing, and if I reverse this thing, instead of 1 cross 2, I'll make it 2 cross 1 and run it. See, you will be able to see these graphs like this. So now in this plot there are 2 row and 1 column. So we can fit 2 graphs into this. Now one thing you can observe over here, in graph number 1 there is no grid, no axis title, no title of the graph, but over here we have written all these things, right? So just remember, whenever you are using this subplot command, after each and every plot you have to write all these details. So grid on, X label, Y label, title and legend, you have to mention each and everything after this plot and before this subplot. So to add all these details to this plot. So now let's copy all these things, paste over here. This is graph of A, that means it is a sinusoidal waveform, right? And this is cosine waveform. So what we'll do, we'll change legend, we'll update it. One more thing I have noticed over here, see, before we update it, over here you just observe There is a warning ignoring extra legend. What it is doing exactly? Over here we are providing two legends, right? Just forget this thing, right? Over here we are using two legends, but in this subplot we are giving only one graph. So in that graph there is only particular one plot. So for one plot we are giving two legends. So what it is doing, it is automatically removing the second legend from the graph, and that is what this warning wants to say, right? So now let's paste it again. Our this section is for sinusoidal plot, it is A, so we'll keep sine wave and we'll remove this cosine wave. Our second plot is of cosine wave, so we'll remove this sine. And now let's run it again, and now you will be able to see all the details are available. Observe over here, the location of this legend is here, and here location of the legend is here. And why it is like this? Because we have written over here location of legend is best possible location. So this is how you can add multiple graph in one figure. Hey man, before you jump ahead, there is a quick short question for you, and that is for your brain test. I am going to ask you a one question and you need to answer that question in comments below. Your question is this: which of the following command is used to add multiple plot in one graph? Remember this, multiple plot in one graph. Your options are this. Think carefully, remember what we have seen in this video, and then write the answer in comment section below. Do not forget to write the answer in comment section below. I am asking this question because it will give you a verification check that whether really you have learned anything from this video or not. Hey, if you want to plot multiple axes in MATLAB graph, then this is the right video for you. Here in this video, we'll learn how to plot two different data range graphs like this into a single graph with two axes like this. So now, without wasting time, let's quickly start the session. First of all, I would like to write these two lines, and now we'll begin with our program. So now I'm going to write the data range for our graph, and there we go. This is the x-axis from 0 to 2 pi on the step size of 0.01. y1 is a sine function of x and y2 is a cos function of x, but it is 19 times, right? So obviously the data range for vertical axis for both this graph is different. We can say that y2 is 19 times larger than y1. Let me show you these two separate graphs and then we'll see how we can add up these two together. So I'll simply write plot for both the graphs. There we go. Plot x y1, and we'll hold on the value in same graph. We'll plot x y2 and let's run it. But we have not saved this file, so when we run it, it will ask us to save. So we'll give the name multi-axis MATLAB plot and we'll save over here. We'll add to path and there we go. So the problem is clearly visible. This data range is so large that the variation in the first graph, right, x versus y1, it's not clearly visible. So to clearly visualize the differences in, maximum value, minimum value, positive, negative, and all those things, we need to separate those axes because the difference in to the vertical data range of both these graphs is very large. So we'll close it. Now we do not require this hold on. What we'll do, write the command y-axis left. So this graph we are going to plot on left hand side and this one on right hand side. So the axis of this graph will be on left hand side and the axis of this graph will be on right hand side. And now let's run it again. And now you can see The blue one, the axis of this blue graph is on left hand side and the axis of this orange one is on right hand side. Let me do small variations over here. So I have increased the line width, so now it's more appropriate to see, right? If you want to give the axis property and title, you can give it over here. And let's run it. And this is how its amplitude of y1, its amplitude of y2, time, and sine and cos function. Oh, I have written it not appropriately. It should be like this function.
Hey there, I am thinking to provide two things. First, a free certification MATLAB course, and a second, in depth structured course with exclusive content, exercise, and support which goes beyond what it's available here, and that is paid MATLAB course. So please let me know by commenting or filling out the interest form in description box below whether you are interested in free certification course or in paid course. Thank you so much.
Right? So this is how you can plot multiple axes in MATLAB graph. If you want to learn anything more on MATLAB, you can write that thing in comments below and I'll try to make video on that topic. Hey, are you looking to learn how to plot 3D graph in MATLAB, right? Then this is the right video for you, because in this video we are going to learn how to plot 3D graph in MATLAB like all of this. Yes. And oh my god, this 3D graph is getting animated in MATLAB. So stay tuned. We will also learn how to animate this type of 3D graph in MATLAB in this video. So let's quickly jump into it. Okay, so now we'll start with very first command to plot 3D graph. This is untitled script. I don't want this. Let's close this thing. This is the script of our previous video. In our previous video, we have also learned that how to plot different varieties of 3D graph. And if you want to learn that varieties of 3D graph, you can watch that video later on. The link of that video is in description and above here in card. But here in this video, we do not want all of these things. So let's remove these things. The things that we do not require, we are going to remove. X label, Y label, Z label, and title that we want, so we'll keep it. So now we'll start with very first command, and that is mash plot. And for that we need to define X and Y. So let me quickly define X and Y. So there we go. This is our X and Y. Now these X and Y's are scalar. If you want to plot 3D graphs using mash, surf, all of this command, then we need a uniform matrix. So to achieve this, we'll use mash grid. So let me write that thing. So there we go. X comma y is equal to mash grid of xy. These are the small x and y, and these two are capital X and y. Now we'll write z as the function of x and y. So there we go. This is z. Now we'll write mash command. And now let's run. So this is a simple 3D plot, and using this rotate button you can rotate this graph and observe. So this is just a simple mash plot. Basically the use of mash grid is to transform the domain specified by vectors x and y into arrays x and y, which can evaluate functions of two variables and three-dimensional, either mash command or surface command. Both of these things is just to give you a mash plot or a surface plot. The rows of output array x are copies of vector x, and the columns of output array y are the copies of vector y. So this is the basic and fundamental of mesh grid. Now we are going to plot a little bit more complex graph than this one. So let's close this thing and we'll make few changes over here. Now we'll replace this z with a little bit more complex function sine of x and cos of y, and we'll change the respective value of x and y. Instead of this 2, let's make it 10, and now let's run. So this is a little bit more complex graph, a plot of more complex function. So this is how you can plot 3D graph using mesh command. The mesh command is used to plot mesh of lines between the points. Now I'll show you one more interesting command to plot 3D graph in MATLAB. So let's quickly explore that. Close this thing. We do not want to use this command now, so we'll just comment it, and instead of this we'll use another command, surf. So this is another command, surf. All of these things will keep as it is, but instead of this mesh we'll use surf. Now let's run. So this is another way to plot 3D graph in MATLAB. You can see this 3D graph. There is a small difference between mesh plot and surf plot. Now we'll try to find difference between mesh plot and surf plot. So we'll uncomment it and we'll plot the surf in another figure. So let's run. This is the figure 1 is the plot using mesh command, and the figure 2 is plot using surf command. So you can see the difference between these two commands. The mesh command is used to create mesh of lines between the points, whereas surf fills the gap with colors between the lines. So this is the difference between surf plot and mesh plot. Hey, are you going to use this command in your MATLAB project? If yes, then write yes in comments below. Some more interesting commands to plot 3D graph and to animate 3D graph is coming up, so stay tuned. Now let's learn how to style this graph. So we'll close this thing, this one also. So now we'll plot only surf command. So we'll comment these things, run it, and you will be able to see only these things, right? So right now there is one simple thing, that the border is being represented with the black line, and in between the gaps is filled with the colors. Now just imagine, what if we have more numbers of points? Then we'll have more numbers of borders. We'll see this thing and observe this graph is fully black because the fill color in between, the area to fill the color in between is very less, right? So the full graph looks so black because all we can see is black lines. So how we can remove these black lines? So let's go through that thing. For that we need to write one line command, and that is shading interp. Let's run this thing and you will be able to see the graph without black lines. So using this shading interp, you can stop plotting these black lines. So this is nice representation of graph without black lines. For your reference, if you want a color bar with this graph, then you can have it very easily. Just close this thing and write one line. Color bar is that line, and run the thing. You can have a nice looking color bar with the graph. So now you can have an easy idea that what color represent exactly what amplitude. This is one type of color. You can even control the color of this graph. Now let me show you how we can control the color of this graph. So for that, close this thing. The command is color map. There are various types of color map that you can see. All of these types of color map is on your screen. So these are the different types of color map which you can use to color your 3D plot. Right now we are going to use color map summer. Now let's run. So this is the color map of summer. Instead of this summer, you can even use winter. And this is the winter color map representation for the graph. There are still much more varieties to this color. Let me show you that thing. Sparula. So this is the basic color map. I don't know how to pronounce that. Parula. But here you can see the gradient of color. But you can divide this gradient into fixed numbers of color. For example, I want to divide full graph into 4 segments, right? So parula 4 and let's run. So full map is divided into 4 colors. You can even change the number of segments you want. Instead of 4, if you want 8, you can have 8 varieties of color. So this is the 8 variety of color. Instead of this parula, there are another color scheme, jet. You can even use this jet color scheme. So this is the jet color scheme. So this is how you can style your graph the way you want. Hey, and now I want you to like this video if you are really enjoying this. And you can subscribe to this channel if you are going to learn similar things in MATLAB. Because here on Learning Vibes, we have created a separate full playlist on MATLAB tutorials. In that playlist, you can learn so many things about MATLAB for your project. Now, after all of this interesting plot, let me show you another variety of plot, and that is waterfall. So for that, we don't want all of these things. So for time being, we'll comment it, and that graph is waterfall. Let's run this thing, and you can see this graph. This is the waterfall type of graph. Let me reduce some of the points so you can have a better idea. You can differentiate easily between surf, mesh and waterfall type of plot. So this is the waterfall plot. At the edge it will look like a waterfall, and that is why it is named as a waterfall graph. So this is the waterfall graph, and now we'll move ahead with another plot. Let's comment it. Now we are heading for another type of plot, that is contour plot. So to plot contour, the command is contour xyz, and let's run. So this is the contour graph. Basically this command highlights the contour line of graph. You know what? You can even control the numbers of contour lines by giving just a small input in the command. So now let's explore that thing. Over here there are many lines of contour, right? So close it. For example, we want only 3 lines in contour. So let's run. So here we have only 3 lines which represent a segment of layer 1, 2 and 3. For example, if we want more lines, say 13 lines, let's run. So now we have 13 lines in this contour. Using more lines, we can more accurately represent the particular segment of the amplitude. So instead of 30, just for fun, let's have 130 lines and see how your contour looks like. La la. So close this thing. We have seen how to plot contour. Now we are going to add some fill colors in that contour, and for that the another command is contour F, and let's run. So this contour F fills the gap with the colors, and you can have this contour F 3D graph. Basically this contour is always 2D because it represents different amplitude of z axis with different colors. So that is why it is basically a 2D representation. So this is how you can plot varieties of 3D graph in MATLAB using different commands. Now you tell me which of these commands you are going to use in your MATLAB project from this video. Write that command in comments below and tell me which one you are going to use. And yeah, I'm out here on Facebook, Instagram, Telegram. So if you want to ask me anything, reach out to me on any of this platform. The links are in description box below. And after that, the time is came for animation. So now let's have some 3D animation in MATLAB. So to have that 3D animation, we do not want all of these things. So we'll just comment it. We don't even want this too. So we'll comment it. And now there we go. Let's run this thing and have our 3D animation.
Have you ever looked at the graph and you thought that this graph doesn't signify anything? It happens sometimes when you are using a standard linear scale for the graph, because the linear scale will suppress some of the information when the range of magnitude is very large. But what if there is a way to reveal those information and have a clear visual of your data that we are looking at? And the solution to this problem is logarithmic plot. Basically, it is very useful when the data covers a wide range of values, or we can say a large variation in magnitude of data. In this type of plot, a linear scale does not play a significant role, but a logarithmic plot can give you a significant clear visuals about your data. So now we are going to understand why logarithmic plots are important and how you can plot those things in MATLAB. So let's get started. Just imagine that you are a seismologist and trying to develop a relation between the earthquake and the amount of energy releases by it. You have collected a set of data on earthquake ranging from, let's say, 1 to 9, and the energy they releases, and the readings are this. And here you can see all this data carries a large range of magnitude. When the magnitude is 1, the energy is 6.3 into 10 raised to 5. And when the magnitude is 9, the energy is 6.3 into 10 raised to 17. So see the vast difference between the scale 1 and scale 9. So here first we are going to plot a simple linear graph. So here we are going to create a simple linear graph between magnitude and energy. And this line will create a grid on the graph. It will give the title to the graph, X label and Y label. And now let's run. You can see here for this range of magnitude, the energy releases by earthquake is not being properly represented in the graph. So this is what the problem happens with the linear scale, and that is what I was talking about earlier. Now instead of this linear scale, we are going to plot a logarithmic scale, and then you will be able to find the difference between linear scale and logarithmic scale. So now let's plot a logarithmic scale. We are going to use the same data to plot the logarithmic scale. There are basically three functions to create a logarithmic graph in MATLAB. The first is semilog x, the second is semilog y, and the third is log log.
In this section, first we are going to use semi-log y, and then we'll go for semi-log x, and then we'll go for log. So here we'll go for semi-log y, and then we are going to copy this because we are going to plot the same magnitude versus energies graph, right? And then we'll use the same commands grid on to give title, x label and y label. A small modification we'll do here because it is not the linear scale, it is the logarithmic scale. And now we are going to run this thing. So here you can see this is the logarithmic graph. You can clearly see the difference when the magnitude is in between 1 to 6. A proper variation in energy releases can be observed through this graph. Now let me combine this linear scale and logarithmic scale and give you a proper visual effect that what is the clear difference between the linear scale and logarithmic scale. So this is the script where I have combined both the graph. Here in this section I am defining my magnitude and energy, and here in this section I am creating a linear graph. This is the command subplot using which I am going to combine two graphs in one figure, right? So it's a linear graph plotting, and here I am plotting a logarithmic graph, and this section is just to give a title and proper positioning to both the graph. So now let's run this section, and here you can observe the difference between the linear scale and logarithmic scale. When the magnitude is from 1 to 6, you cannot see any changes in the energy scale. But in logarithmic scale, when the magnitude is from 1 to 6, you can see significant difference into the energy scale. So it is not suppressing any information into the graph, whereas linear scale suppresses the information into the graph. Now here in this example, we have understood it using semi-log y. That means we are using logarithmic function in y scale. But what if I want a logarithmic function on x scale? So now let me modify this code for logarithmic function on x axis. So I'll just copy this entire code, and instead of this semi-log y, what I'll do, I'll use semi-log x. Just run this thing and we can have logarithmic scale on x axis. But here in our example, if you use logarithmic scale on x-axis, your problem will not be solved. Why? Because for our example, the data variation is on energy scale and energy scale is on y-axis. So when the data variation is large, when the magnitude is large on y-axis, you should go for logarithmic scale on y-axis. Instead of y, if the data variation is on x-axis, the large data is on x-axis, then you should go for the logarithmic x or logarithmic function on x-axis. But now, what if both the axes have the large variation of data? In that case, you should go for x-axis as well as y-axis, both the axes on logarithmic scale. So how to achieve that? Now we are going to learn that thing. So we are going to copy and paste the same code, but instead of semi-log y, we are going to use log. This log function will plot logarithmic graph on x-axis as well as y-axis. Now let's run this thing, and you can see on x-axis we have logarithmic scale. The same way on y-axis also we have the logarithmic scale. So that's how you can plot a logarithmic graph on MATLAB. Here first we'll understand how to enter matrix into the MATLAB, and then we'll see how to do standard multiplication division and element wise multiplication division to the matrix. So now let's jump to that thing. Let's code it. The first way is you just separate each element by comma like this, 1, 2, and if you want to jump to the next row, then press enter and then start writing the next row like 4, 5. So this would be the matrix A, which is 2 cross 2 matrix 1, 2, 4, 5, right? Another way is inline addition of matrix, like B is equal to, here you separate each element by space like 1 space 2 space 3, and when you want to switch the row, just give semicolon and then 4 space 5 space 6 like this. bracket over. So this is the another way of adding matrix. Now let's add another matrix like x, which is equal to 1 comma 2 semicolon 3 comma 4 bracket over. Right, so these are the different ways to enter the matrix into MATLAB. Now let's run. So here you can see we have got A, B and C, three different matrices. And now we'll see different arithmetic operations with MATLAB. Like for example, if you want to add to matrix, just simply say R is equal to A plus B. Run. Oh sorry, X, right? Here the dimensions are same. So when you do addition and subtraction, let me show you subtraction also. Let's say t is equal to A minus X, right? And run. So here you can see addition and subtraction. So when in MATLAB you are doing addition and subtraction, it will be automatically done element wise, because in normal matrix also it is done element wise. In addition, what it will do, it will add this one with this one and gives the answer as 2. So in R the first element is 2, second is 2 plus this 2, that gives us 4, then 4 plus this 3 gives us 7, 5 plus 4 gives us 9. So in matrix addition and subtraction is done element wise, right? But what in case of multiplication? Let me show you that. For multiplication, let's say we have two matrices A and B. So here A is 2 cross 2 matrix and B is 2 cross 3 matrix. So in order to multiply these two, what is the condition that must be followed? The condition is the inner dimension of these two matrices must match. And here the inner dimensions are matching, 2 and 2. And what would be the size of resultant matrix? That would be 2 cross 3. 2 from A and 3 from B. So that will be the size of that matrix. And the calculation is does like this. C is equal to 1 multiplied by 1 and then 2 multiplied by 4, and then adding these two things together gives us the first element of C. The same thing with second column. 1 with 2 and 2 with 5 gives us the second element of this 2 cross 3 matrix, and then the same thing for the rest of the elements. So this is how we get our final matrix, which is 2 cross 3 in size, that is C matrix. Now let's see the same thing in MATLAB. C is equal to A cross B. Let's run it, and which is 2 cross 3 matrix. So this is how a standard multiplication is done in MATLAB.
Hey there, I have provided this complete MATLAB course for free, and I hope it is very helpful and valuable for you. After learning from this course or after completing this course, if you find it valuable for you and if you want to appreciate my efforts, please do consider donating. Your support will help me invest more time and resources into making even better tutorials and provide valuable learning experience for you. You can find the donation link in description box below. So thank you so much for your support.
But this type of multiplication is not required in all the applications. Many calculations does not fit into the standard matrix multiplication. For example, a car is moving and you are recording the data of force applied and the velocity of the car to calculate the power produced by that car. The data you are recording is in Excel format, and that would be in a long vertical or horizontal list. Yes, actually you can import the data from Excel to the MATLAB. If you want to learn that, then here is the video for that. But you should check that video after this. Here our purpose is to understand how to do element wise multiplication. So now let's see how to multiply this force and velocity. So now let's say, for example, the reading of force that we have taken, it's like this, and the reading of velocity we have taken, it's like this, right? we want to calculate power. So here both these things are 1 cross 6 matrix. What is the equation of power? The equation of power is P is equal to force into velocity. Now if you want to multiply these two things together, the inner dimension must match. So if force is 1 cross 6, then the velocity must be 6 cross 1. But if it is 6 cross 1, then also we will not be able to get the right multiplication, because the matrix multiplication does not fit for the application. Now here our requirement is different. Here our requirement is to go for element wise multiplication, because the value of force is 1 here and the corresponding value of velocity is 1. The value of force is 4 and the corresponding value of velocity is 4. Here our requirement is to multiply the 4 with 4, not with any other element. So here we must go for element wise multiplication, and the result that we want to get is like this. So this is what our expectation is, and to achieve this we should go for element wise multiplication. Now let me show you in MATLAB. Let's add force here. So we have added the two matrix, force and velocity, and now we are going to multiply it. So here in between this cross mark there is a dot, F dot cross V. So this dot represents that whatever multiplication you are about to do, that has to be element wise multiplication, and when you do this, the result would be like this. Now instead of this, what if you go for regular multiplication and now run? There is an error. Inner matrix dimension must agree or must match. So this is how you can achieve element wise multiplication. The same way you can do element wise division, right? So this is element wise division. There are so many things that you can do with this matrix in MATLAB, and if you are interested in learning that thing, then you must refer these videos.
Alright, let's get started. Transposing a matrix in a MATLAB is a simple but powerful operation. You require this type of operation in many calculations like linear algebra, machine learning, control theory, and many more. And in this video I am going to tell you how to do transpose of simple matrix as well as transpose of matrix with complex number, because it is tricky to do transpose of complex number. So without doing any delay, let's get started. Okay, so now let's take a matrix. So this is our simple 1 cross 3 matrix. Now there are two ways to do transpose of this matrix. The first way is by using command. So let's say B is equal to transpose of A and run. So previously A was 1 cross 3 matrix. Now that has been converted to 3 cross 1 matrix. So B is transpose of A. And now if you do not want to use this command, then the next method is even simpler one. C is equal to A dash or A single colon and enter. So taking transpose is quite simple. Just you need to write transpose or you need to write colon, single colon. Now taking transpose of complex number is a little bit tricky. So now let me show you how to take transpose of complex number. Let's say A is equal to this. So this is our matrix with complex number. So now if we take transpose of this matrix, B is equal to transpose of A. Then here the complex conjugate transport operator A dash also neglects the sign of imaginary part, and because of that here the sign of imaginary part was minus, and after transpose we are getting plus, and here the sign of imaginary part was plus 1, and instead of that here it is minus 1. Now instead of this, what if you want the same value to be transposed? So for that you need to make this little change. A
dot transpose, and there you go. So this will become element wise transposing, and this will intact the sign of complex part. So that's how you do transpose of simple matrix as well as matrix with complex number. To explore more on MATLAB, you can visit this playlist. So see you into the next video.
When you are working with matrix in MATLAB, there are several requirements that you need to fulfill. What if you need to work with a specific element of that matrix to work with? Or you need to work with specific row or a specific column? Or you want to work with specific set of data from that matrix? How to achieve all these things? This is MATLAB dashboard, and now we'll work with the element extraction from the matrix. This is the script of our previous video where we have did standard matrix multiplication and element wise matrix multiplication, and that is really important when you are working with matrix in MATLAB. So if you are interested in learning that thing, then after this video you definitely go and watch that video. That would help you a lot. But for time being, we are just commenting it out. Okay, so this is our matrix A, and now we'll run it. Let's change the folder, add path. So this is our A matrix, right? Now suppose I want to extract this 5. So what we do, we'll create another variable where we'll store the value of 5, and we'll say b is equal to, and now we need to specify the location of this element. It is the part of matrix A, so it's A into bracket. Now we need to specify the location of this element. It is in second row and second column. So we'll write 2, 2 row and column, and that's it. Now let's run it again. Now you can see that 5 is extracted from the B. The same way, what if you want to extract entire row? For example, we want to extract this third row, right? So again we'll create another variable. That row is the part of matrix A, so A into bracket. Which row we want to extract? Row number 3. So it's third row, comma, which column? So in third row there are multiple data, right? So there are 3 columns. We want element from all these 3 columns. So what we'll do, we'll write colon. That represents we want entire column, right? So now let's run it again. And you can see here we have 7, 8, 9, the entire third row. Instead of this third row, what if we want a second column, entire second column, 2, 5 and 8. So here we'll make another variable, A into bracket. Now we want elements from all the rows, right? So we want all the rows and column number 2. So to represent all the rows, we'll use colon and comma second column. Now let's run. So here we have entire second row. Now what we are going to do, we want to extract a specific set of data from this. For example, we want to extract 4, 5, 7, 8. So we'll make another variable, e is equal to, and the data set is the part of A. So now our data set is 4, 5, 7, 8. So it's starting from column number 2 up to column number 3. So what we'll write, 2 jam 3, comma, and in columns it going from column number 1 to column number 3. So 1 jam column number 2. Sorry, it's not 3, it's column 2. Break it over, and now for example we don't want to see these datas, so let's hide all of them and run. So there we go. Here we have 4, 5, 7, 8. So this is how you can extract a specific set of data from entire matrix. And now it's time for the Excel sheet. It may be possible that you are working with the larger Excel sheet like this. maybe you work with this much of big data set or even larger data set than this. But what if out of this entire data set, if you want to extract only this column, or if you want to extract only this row, or you want to extract only this much of data set, a specific data set from the entire Excel sheet, from the huge data. So how to extract those data for your working, that is what we are going to learn in this video. Now we'll learn how to extract a specific set of data from this Excel sheet to our specific variable. So first, let's import this Excel to our MATLAB. Just remember this thing that the name of our Excel sheet is data, right? And now let's jump to the MATLAB. And here we have imported that entire Excel sheet, and you can see here it is available in Workspace. Double click it and it will open. Now for time being, let's make it smaller so that we can see this entire data set. So this is our entire Excel sheet. So now we are going to work with this data set. But first thing, if you don't know how to import Excel sheet into MATLAB, or if you don't know how to import multiple Excel sheet into MATLAB, then you can refer my another video. The link will be in description and here in I button. So that's very important and interesting video. You can watch that later on. Right now focus here. Once we have the entire data in our MATLAB, now how to extract the specific set of data. Now from this entire data set, what if you want to extract this column number 3, the all data available in column 3. So what we'll do, we'll make a variable, we'll call it as AA is equal to, first we'll locate the location of data. Where is that data? So that data is a part of data variable, so we'll notify it as data, then dot. That means now we'll go further deep into that data, what we want to extract. In that data, one variable is named as data3, so we want to extract all the elements from that variable data3, so we'll write it here as data3 and enter. So there we go, we have all the elements available in data3 variable. So what we did here, we have just extracted entire column, or we can call it as we have just extracted entire variable from that data set. Now let's remove this. Now what if you want to extract this entire row? For that we'll make another variable, bb is equal to whatever data we want to extract. That data is part of which entire data set? That is the part of data set. The name is data. Then into bracket, what we want to extract? We want to extract entire second row. So row number 2, and what are the other elements? The other elements are row 2 and all the elements from all the columns. So for all the columns, we'll make it colon, bracket over and run. So here you can see we have row number 2 and all the columns. Previously we have extracted this data3 variable into AA, and the method that we have used is like this. So this is how previously we have extracted the data3 variable. There is another way to extract the same data, and that way is let's make a variable cc is equal to data, and what do we want? We want entire column number 3. So the elements, the location of elements are all the rows and column number 3. So for all the rows we'll use column, and column number 3, it's 3. Let's run. So this is another way how you can extract entire column. Now we'll go for a specific set of data. For example, you want to extract only this much of data from column number 4, right? So it's from row 6 to row 10. You want to extract only this much of data from this column number 4. So how to extract that? Let's learn that thing. For example, we'll make a variable name as dd, and now we want to go for row number 6 to row number 10. So here you need to write 6 gem 10 or 6 colon 10. That shows that specific location of rows which data you want to extract. So it starts from row number 6 and goes up to row number 10. Then column, which columns data you want? It's column number 4. So 4 here, bracket over and run. So you can see here we have got the specific set of data from that entire data set. Now let's see, what if you want to extract a specific multiple data set like this, a submatrix you want to extract from this entire table. So now let's make another variable, name it as ff, and then we'll name the data set, which is data. First we'll specify row, it's from 6 to 11, so row 6 to 11, comma, column 6 to 8, so 6 to 8, bracket over, and there we go. So this is how you can extract a specific set of data from the entire Excel sheet. Now I'm giving you a short tutorial to practice. Just do that practice and then let me know that have you did it properly or not. The tutorial is you need to extract entire row 18 and 19, right? So this is what you need to extract from this Excel sheet. I'll share this Excel sheet with you. The link will be in description box below, and using that Excel sheet you need to perform this tutorial. If you want to discuss anything with me on MATLAB, then you can join me on my Telegram channel, or if you want to make any MATLAB project, coding or simulation, then you can discuss it with me on my Telegram channel and then we can work out on that thing. If you are working with large or medium large size data set in MATLAB, then this video would help you a lot. Many times happens that you need to find maximum value from that large data set or minimum value from that data set, or some logical values like values in between 0.5 and 1, values greater than 0.8, values less than 0.4, or any numbers of logical values you want to extract from that large data set. How to do that? That is what we are going to learn in this video. So without wasting time, let's get started. Okay, so now first we'll prepare the script for this data extraction. This is the script of my previous video where I have explained a standard matrix multiplication and element-wise matrix multiplication. If you are new to MATLAB and learning MATLAB, then this is very important to know. If you want to know, then you can check out those things later on. Right now, let's prepare a new script. We'll start with CLC. First, we'll import a large data set. Let me show you a large data set. For example, this is the large data set that you are working with, or this could be even larger than this, 10 times, 100 times larger data set than this. Size does not matter for now. So what we'll do, we'll import this Excel data to our MATLAB and then we'll work on that. So now let's jump to MATLAB. Okay, so there we go. We have imported that Excel sheet to MATLAB. If you don't know how to import Excel sheet into MATLAB, then you can check out this video. There I've explained in detail how you can import each and every column or multiple things in Excel sheet, right? So right now we are not discussing that thing. So first here you can see this data is in table format, right? Double click it and you will be able to observe this data in table format, right? So we do not want this, because for our process we want the data in double format. So first we'll change the data type is equal to, with this command you can change the data type from table to array or a double data type. Run it and it will ask you to save. I have saved it and then run. So here you can see All the details are same, but now the data type is converted to double. Now we can work on that. This is our entire data set, right? So now let's close it. Now directly if I'll explain you with this large data set, it would be tough for you to understand. So what we'll do, we'll take one more data set. Let's make it like this. And we'll suppress the output every time we do not want this large data to appear on my command window. So we'll suppress it and run. So we have another matrix B with this varieties of things. Let's make few changes here, right? So that we can have a real genuine varieties of data. Okay, so now this is our B matrix and this is our large data. So what I'll do, I'll explain you process on the small data set, and the same thing can be applicable for the large data set. Now let's suppose you need to find the maximum value from this B. So when you write C is equal to max of B, it will give you the maximum value from all the columns. But what exactly you want? You want one biggest maximum value from entire matrix. But when you just write max of B, what it will give you? It will give you the largest value from the column. So from first column the largest value is 9, from second it's 21, third 17, and in last it's 16. But this is not what we want. We want 21, because here you can see the 21 is the largest number. So for that you need to write max of B, run, and there we go. You have C is equal to 21. So this will give you one single element, the largest single element from the entire matrix. You can do the same thing with other method like CC. This will give you the same result. C and CC will be the same. Run it and you can see C and CCC, they both are 21. So these are the different ways to find single element, the single largest element from the entire data set. Now let's perform the same thing for our A variable. Now we don't want this thing, so we'll remove it. Sorry, we'll not remove it, we'll just make it comment so that you can note it later on if you want. So this D will be the maximum value from A matrix. This is error because I have not closed the bracket, right? It's my mistake. Let's run it again. So the maximum value is 0.9934. If you want to check this whether it is true or not, you can just rewind the video and check that Excel sheet when I'm showing entire Excel sheet where you can see all the data. Now the same way you can even find the minimum value. Let me show you quickly. The smallest value here is 1, right? So this is how you can find the maximum and minimum value. Now let's comment it. Now in this large data set, let me show you this thing. In this large data set, what if you want to find maximum value from only this much of data, right? From column 1 to 3 and row 1 to 5, or any random column you want to find largest data from any random column. This is the area from where we need to extract the maximum value. So how we can do it? Now here you need to specify the numbers of rows and columns that you need to consider. So the row is 7, 8 and 9. So we'll write 7 gem 9, comma, column numbers are 3 and 4. So we'll make it 3 gem 4. Bracket over, another over, and finally over. And let's run. So the answer is 0.9640, and just verify 0.9640. This is the largest number. So using this method you can extract maximum value or minimum value from selected area of the large data set. Now, what if you need to find the exact location of that large data or indexing of that large data? For example, here we have got the answer that 21 is the largest number from this matrix. But what if you want the location of that number, that it is situated in row number 1 and column number 2. So 2, 1 is the exact location of that number. So how to identify that location? So now I'll tell you that thing. For that indexing, you can write f comma, let's say I for indexing, bracket over, is equal to max of b. Run. So here f gives maximum value from all the columns and I gives the indexing. That means in column number 1 it's third element. In column number 2, it's first element. In column number 3, it's second, and here it is third. So it will give you indexing of that number. Now what we aim to do, we need to find the location of the largest number from all these things, right? So again we'll do the same thing. This time I'll make it small I. So now what I am doing, I am finding the largest number from this matrix and then the indexing of that number. So here the largest number is 21 and the index is 2. So now I'll tell you how we'll find the exact location of this 21. Now here h is equal to I of small I comma small I bracket over. Here this I of I gives us the number of row and I gives us the number of column. So this row and column gives us the exact location of our number. So now let's run. H is equal to 1, 2. So row number 1 and column number 2. This gives us the exact location of our number. Now let's do the same thing for our matrix A, the large data set, right? So instead of this B, we'll replace it with A. Let's run. So it gives us the number 3, 2. That means the highest number is 0.9934 and the exact location is row number 3, column number 2. Let's open A. Row number 3, column number 2. Here it is 0.9934, 0.9934. So this is how you can find maximum and minimum data from the entire data set, from any size of large data set. There are many ways to solve algebraic equation in MATLAB. Here in this video, we are going to discuss two of them. So let's begin with method number 1. For example, we have this equation 4x plus 7 is equal to 0 and you need to find the roots of this equation. So in method number 1, we do not write this entire equation in MATLAB, but instead of writing equation, what we'll do, we'll represent this equation as a matrix and then we'll find the root of this equation. So now let me show you how to do this. So here we have in our MATLAB, we'll take a new script, CLC. So here the equation is 4x plus 7 is equal to 0. The corresponding matrix is like this, f is equal to 4 and 7. The 7 represents the coefficient of constant and 4 represents the coefficient of x. So to find the roots of f, we'll write roots of f. And now let's run this thing. So the answer is minus 1.750. Let us try another equation. Now instead of the simple equation, we have equation with 3x square minus 4x plus 7. So the corresponding matrix to this would be equal to 7, which is coefficient of constant, then minus 4, which is coefficient of x, and then after x there is x square. So the coefficient of x square is 3. The same way we can go for n numbers of power of x. So here we have this equation, and corresponding matrix to this equation is 7 for the constant, then coefficient of x is -4. So after x there should be x square, but in our actual equation there is no x square. So what we'll do, the coefficient of x square is 0, but in matrix you need to go in this sequence only: constant, then x square, then x cube, then x raised to 4, and so on, right? So in this manner you need to proceed. So now there is no x square, so coefficient is 0, x cube is -5, and x raised to 4 is 2. So now what we'll do, we'll go to MATLAB and solve this equation one by one. So first we'll solve this. F is equal to 3 minus 4 and 7. We'll call it x. Roots of x. We do not want these two things, so we'll subtract the output. So here we get two roots of x, the first one and the second one. Here is the real number and the imaginary number. Now we'll go for the third equation. This one. So these are the different possible roots of z. So this is how you can solve the algebraic equation using this roots command. Okay, so now it's time to explore the second method through which we can solve the equations. This method is not limited to algebraic equation. You can solve many equations using this method. So first you need to define a variable as a symbol, and for that you need to write syms. Let's say we are defining this y as a symbol, and now we'll write solve. We'll write this equation. Here the equation was 4x plus 7, right? So instead of 4x plus 7, what we'll write is 4y plus 7. This was the equation, and now let unsuppress it, and we do not want to see this thing, so suppress it. And now let's run. So here you can see the first answer is of roots of f, and the second answer is from this solution. Now here you can see the answer is in -7/4 format. If you want to be more precise like this, then you can convert it into double. And there we go. This is your answer, -1.7500. Now let's solve another equation, the third one. Now let's implement another equation. Now let's run this thing. So here you can see the both are same. The difference is just in sequence. The rest of the things are same. So this is how you can solve algebraic equation in MATLAB. Hey there, we are going to explore two of very important things while solving equations in MATLAB. And this can be very useful when you are dealing with varieties of equations in MATLAB, or even while you are solving mathematical equations for your research purposes. So now let's dive into it. Here first we'll start with syms command. Basically it is a shortcut for constructing symbolic variables. This will be very useful when you are dealing with solving symbolic equations. Let me show you the difference between normal equation and symbolic representation. For example, here I am writing this normal equation, and when I run this, it shows undefined function or variable b, because it's obvious that we have not defined any variable, so it will clearly shows us an error. But when you use the syntax and mention all these variables b and c, and then again write this equation and then press enter. Now here also we are not defining b and c, but what it does, it takes this b and c as a symbolic variable. You can see here the type of variable, it's sym. That means it's a symbolic variable, symbolic representation of a variable. Now let us take an example to better understand it. So here first I am clearing all the workspace variable, then I am clearing the command window, and then I am defining syms b and c as symbolic variable. And this is my expression. And now if I want to solve this expression, I need to use the command solve. Solve into bracket which equation I want to solve. The equation is a, right? So now when I run this thing, it shows a is equal to this, and now we are solving the a is equal to -5 into b raised to 2. So what it does, it solves this equation symbolically. So here I have two variables, b and c. So when I solve this equation, it will solve the equation for the higher alphabetical number. The higher number is c, so it will solve the equation for c, and that is why we are getting answer as -5 into b raised to 2. Instead of this 2 variable, let us add one more variable, that is d, and we'll write 5 into d. And now let's run it. So here our solution is -b raised to 2 minus c by 5. So this is a symbolic solution, and it is solving for d, right? But now let's say you have some specific requirement that instead of d, I want to solve this equation for c. So what you're supposed to do, you need to write solve a, comma, you need to define the variable for what you want to solve the expression. Here in our case, we want to solve it as c. So we'll mention c and then we'll run. So now here you can see the expression is solved for c. The same way you can do with b. Instead of c, we want to go for b, and there we go. Here we have the expression for b. You can even solve the multiple equations in line. Let me show you what I mean to say. Here I am defining three variables, a, u and v. Here su is my first variable, sv is my second variable, is equal to solve, and into the bracket, this is my first equation, comma, this one is my second equation. So here I am defining two equations, and now let's run this section. So we have the solution su and sv. You might be wondering that what I did, I have just run this particular section. This is a different section and this one is also a different section. How to create this section? Using these two plus sign. But what are the advantages and use of these sections? For that I have a separate video. You can watch that video to learn a very handy use of the sections. How you can use these sections and what is the importance of using sections. And the shortcut key to run only particular section is Control Enter. So it's very simple. Left hand side is our variable, then equal to solve, into the bracket our equation number 1, then comma, and equation number 2. If you want to add more equations, then add comma and then upcoming successive equations. But the same way you need to provide the successive variables also. Now what if instead of this a, I have multiple values of a, and I want to place that multiple values of a in this equation and then go for the varieties of solution. So what we'll do, we'll remove a from here, we'll add, value of a changes from 1 to 10 in the step of 10, and then end. Let's run. So here we have 10 different values of SV and SU. But all these answers are symbolic representation of answer. If you want a real number in answer, then you need to write. And now run the same thing. But this time what I don't want to clear it all. Why? I'll show you why I'm doing this thing. So now let's run. So here it is, the symbolic representation of the answer. This is one of the way to represent the answer, but when you convert this symbolic representation to number, we'll get this numeric solution. So to convert the answer in numeric solution, you need to add this double. So I think this much is clear. Now it's time for the second interesting thing, and that is subs. S-U-B-S. This will do the symbolic substitution in equation. The syntax of subs is like this. Subs into the bracket S, old, new, bracket over. S is the equation or expression. Then this is your old variable and you want to replace old variable with the new variable. So here you need to place your new variable. So using this subs command, you can substitute your older variable with new variable, more complex, with more additional information, or with some numbers. So this is what you can do with subs.
Hey there, I have provided this complete MATLAB course for free and I hope it is very helpful and valuable for you. After learning from this course or after completing this course, if you find it valuable for you and if you want to appreciate my efforts, please do consider donating. Your support will help me invest more time and resources into making even better tutorials and provide valuable learning experience for you. You can find the donation link in description box below. So thank you so much for your support.
So now let's take an example of this for better understanding. So what we'll do, we'll use the same command here, clear all CLC, sims B, C and D, and now we'll go for subs. So we want to substitute, so first you need to define the expression. So we are defining that we want to substitute anything in expression A, now the older variable. For example, instead of this B, I want to use D, right? So my older variable is B and the variable that I want to place instead of B is D. Now bracket over and let's run. So this is my solution, 5D square plus 5D plus C. But now you wish that instead of only B, I want to replace B and C both with some new variable. So for that, curly bracket, you need to define older variables B and C. These are the two older variables that you need to change. Then again comma, and now in curly bracket you provide your updated variable. For example, instead of B, I want to replace 3D. Right, so what I'll write 3 into D. So B will be replaced with 3D and C, I want to replace C with D square. So here I'll write D square, bracket over, and now let's run. So here you can see this is my solution, 46D square plus 5D. So what is happening? B is replaced with 3D and C is replaced with D square. So in substitute you can use variable or combination of variable to replace with. Now here I can directly use instead of B, I want to replace 5, right? Control enter. So it will replace 5 with B. Sorry, I have written D. So instead of D, it's 5. So 5 into 5, it's 25, right? So here I am replacing B, C and D with 5, 4 and 5 by 6. And this is the result of my substitution. So here in this video we have learned two important things. The first thing is symbolic representation with symbolic solution, and then symbolic representation with symbolic substitution.
You can do varieties of things while working with MATLAB. For example, the more humans we have on the earth, the more babies we can have. Then those babies will grow up and that produces even more babies. The population will grow faster and faster. The world's current population is around 8 billion, and when you finish watching this video, till that time around 2000 babies would have been born. But the question is, why I'm telling this to you in MATLAB tutorial video lecture series? Now that's the point. If you want to do research or study, like how much population changes by time, or you are dealing with control system when your input changes in step and you need to make some changes in output in accordance with your input, then you need to use differential equation. Now for example, we have an equation 2 minus x square and we want to differentiate it with respect to time. So let's write a script for that. So let's say our output has two variables. One is t, time, and the another one is x. And now we want the differentiation. So we will go for command ODE. ODE represents ordinary differential equation. And there are varieties of method through which we can solve ordinary differential equation. Here we are using ODE 23. Now into bracket, first we need to define ODE function. Here you can see, first we need to define ODE function. Let's say suppose our function is f. Then you need to define t span. T span means your time span, for what amount of time you need to differentiate this equation. So let's say our time span is t, and then the initial condition. What would be the initial condition of x? So let's say our initial condition is 1. So this is the equation. But here we have not defined the time span and function. So what we'll do, before this equation we'll define time span and equation. So let's say this is our time span, and now I'm going to define the equation. There are various methods to define equation. One of the simplest method is inline equation, defining equation in line. So for that we'll write, what is our equation? Our equation is f. So we'll write f is equal to, we have variable t and x. So f is equal to @t x, and now into this bracket we'll write our equation, and the equation is 2 minus x square. So there we go, and now we'll save it and run it. And these are the different results of differentiation. Now let's plot these results into the graph. If you want to have smooth curve instead of these slanted lines, then here you increase number of points and then you can have a smooth line. So this is one of the way of solving ordinary differential equation. Now I'll show you some another method. Now for example, our equation is minus y plus ku by x. This one. And we'll solve it a little bit differently. So we'll write ODE equation for this. Now instead of ODE 23, we'll go for ODE 45. Now first we need to define ODE function. Let's say our function is f. Now we'll define time span. Now here we'll define it a little bit differently. We'll say 0 to 1, comma, and now we need to define initial value y0. I can directly put the y0's value, or I can take this as a variable and then define it in the same script above. So here first we need to define x. So I've just randomly defined x is 4, k is 2, u is 1 and y is 0.5. And now we'll plot this t and y. And this is the result. See, this one is the simple function. But what if your function is more complex? In that case, you can create a separate user-defined function for your specific function, and then you can directly call that user-defined function here with this ODE function to get the differentiation of that equation or your function.
There are many devices which collects the data and share it. The data logger is one of the example of it. Now let's suppose you are collecting a multiple data from weather station. Data like temperature, humidity and wind speed. The weather station shares you data in a huge text file. And now you want to analyze this data for research purpose. So the first question comes in your mind is,
how to import this huge text file in MATLAB. And in this video, we'll see two methods to import text file into MATLAB. So without wasting time, let's get started. So first, in Home tab, just click on the import data and then go to the folder where your text file is placed. So let me jump to that folder. So here, weather data 1, that is our text file. So when you select that text file, it will pop up in this way. And let me also show you how that text file looks like, right? So this is the real text file that we have just imported, weather_data_1. So this is the file that we have imported, and the same thing you can see over here. Now minimize it and see all the data is available in table format, right? So what we'll do, we'll just right click and import the data. Now just close it, and here you can see the data has been imported into the table format. Now when you double click this table, all the data has been automatically separated from each other. From here you can rename the variable, right? So this is the name of the variable. Let's call it as read. This is the reading of temperature. So I have updated name of all the variables, readings, temperature, humidity and wind speed. And when I was changing the name, the similar command execution you can see into the command window. So by writing this command, you can change the name, or by directly changing the name, you can implement this thing. So it's just a vice versa process. So now let's close it. Now if you want to extract some of the variable from this table, then you can easily do it. Let's say the first variable is named as read. So by writing this line, you can extract this entire read variable. For that, what you need to do, you need to write the name of data set, that is weather data 1 dot read, and just run this section. And you can see here we have created new variable named reading, which is 40 cross 1 matrix, and you can see here this is 40 cross 1 matrix. The same way you can do this for all these 4 variables. So that's how you can store all the columns of this data set into the different variables. Now let's run this thing and see. We have got humidity, reading, temperature and wind speed. All are 40 cross 1 matrix. All you can see here. And then using this data you can do any analysis you want to do in MATLAB. Now it's time for second method, and after this I'll show you how to plot this text data for analysis. In second method we are going to read entire text file using commands, and to do that the command that we are going to use is read table. So what do we supposed to do here? This is the name of our new variable data. The command we are going to use for this is read table, and we are going to store all the data into this new variable called data. So in first place you're supposed to give entire path of your text file. So what do? We'll just delete it. We'll go to the folder where our actual file is located. So here our actual file is located, weather_data_1. We'll copy the entire path and just paste here. Now if you see entire path, it's very long. If we write this entire path over here, it becomes very long. So what do? We'll make another variable file path, and over here we'll write file path. So instead of writing this entire path, we'll just write file path, and this file path means this section. Over here we have just specified the location, the folder of that file. But in that folder there are varieties of files, right? So in that folder, which file we are talking about, that we need to mention. So at last we're supposed to write the name of the file, and that is this weather_data_1. So we'll write over here .txt. Okay, so we have given the path. Now it's time for this section, header lines. What does this header lines means? Let me show you our text file. This is our text line. In this first, second, third and fourth, these 4 lines are just information, and after this 4 line our actual data begins, right? So this 4 lines is known as header lines, and we want to skip these lines. We do not want to include this line as a data, right? So what do we do? There are 4 lines, line 1, 2, 3 and 4. So we'll mention header lines is 4. So what it does, when it reads that text file, it just skips the first 4 lines, and the remaining lines it will take it as a raw data, the real data. So here first we'll delete all these things. Okay, so enter a workspace is empty now. And now let's run this section. So here you can see this is our file path and this is the data, 40 cross 4 table. Just double click it and here you can see the entire table has been imported. And over here by default name of all these variables are var, variable 1, 2, 3 and 4. The same way as we did earlier, if we want to extract each and every element into a separate variable, then we supposed to follow the same process. Just close it and we'll run it again. And here you can see humidity, reading, temperature, wind speed, all are stored in a separate variable. And now I'll show you how to plot the graph using this data. So this is the section that we have added, and let's run this thing. And this is the graph. Here you can see it is graph versus temperature versus reading, humidity versus reading, and wind speed versus reading. Here we have a transaction data and we'll do some process on it, and then we want to store this data in specific format in text file. Let me give you an example in which format I want to store this data. Let's say this is the text file and in this format I want to store this data. So what we'll do in this video, we'll write a code in MATLAB through which we can generate this type of text file in specific format, this format that we want. So we'll start writing the code. One of the things that we want is total of all the transaction. So here we'll write, this is the variable total, and in this total variable we are going to have this summation of all these transactions. Now we'll write the program to generate the text file. So for that we'll create a command to open a file and then we can write in it. So this is FID, it is basically a variable which has been assigned to our text file so that MATLAB can identify we are talking about which file. The main thing is this fopen. This command will open a new fresh text file. What will be the name of the text file? You should write the name of the text file over here. Whatever name you want to give, you should write it over here. So the name we have given is transaction underscore report.txt because it is a text file. Then here you should specify what is the operation you want to do. Here we have written W, means we want to write. Instead of W, if you write R, that means you want to read. So you can read text file and you can write text file through this command. Now we have opened the text file and then we are going to start writing something in that text file. So let me show you the sample text file. This is our sample text file. So first thing that we want to write in this text file is transaction report. And in order to write something in text file, the command is this. Using this fprintf command, you can write something into your text file. So first we are specifying over here FID. That means we are talking about which text file. Once we have identified that thing, then comma, and in inverted comma write transaction report. It is a simple plain text which you want to write into that text file. Then finally this section /n. This /n indicates the end of the line and cursor will jump to the new line. So over here /n and then inverted comma over, bracket over. So first let's run this much of program. Over here you can see in our current folder there is no text file, right? So we'll run this thing. Once we have run, a text file will appear over here, and the name of that text file is transaction report. Let's jump to this current folder, copy the path. So here we are, and here you can see transaction underscore report. And if you open this file, you can see over here transaction report. So we have written up to here. Now our reference text file is like this. So first line we have completed, and in next line we want this type of dashed, and after this dash we want total transaction jam 5. So now let's do this thing. Now this line is the same as we have written previous line, right? All these are just a simple plain text. Over here we have used dash, then slash n to end the line and jump cursor to the next line, then again slash n, so the cursor will jump again, so that we can have a blank space of a single line. Then over here again we are writing fprintf, and in this case now we are writing total transaction jam. This percentage sign is really important because it indicates something specific. This percentage sign indicates the start of the format specifier, and the D indicates insert integer value. So together percentage D means format specifier which used to insert integer values into the formatted output. And which integer value it will insert over here in place of D? This one, length of transaction. What is the length of transaction? It will count the length of this variable, and it's 5, so it will place 5 in place of T, then slash n and slash n. So now let's run this program up to here, and now let's open that text file again, and you can see here total transaction is 5. Now we are going to write each of the transaction in vertical format, like this transaction detail and all this transaction separately, and then we are going to write the sum. So let's close it and implement this section. So here in this line we are just adding transaction details. It is just a simple plain text as a title, transaction details. Let me show you our desired text file side by side so that you can have a better idea of it. So this is our desired text file. So this line is added because of this line number 11. Now here we use this for loop to print all the transaction in specific format. Here this loop starts with I is equal to 1 and goes up to length of transaction, which is 5. Now in next line, line number 14, we are again printing fprintf. What we are printing? First we are talking about this file, and then we are printing transaction. So this is the transaction. After this transaction we are writing percentage D. What this percentage D means? Percentage D means this I, and I indicates what? I indicates this number which starts from 1 and goes up to 5. I1 means first transaction, I is equal to 2 means second transaction. So whatever value of this I we have, it will be placed over here as D. Then this jam, then after this dollar sign, it is just an symbolic representation. But after this dollar sign there is a percentage sign, dot, 2 and F. Together this thing means something. Percentage sign indicates the start of the specific format, whereas this dot specify the precision. So after this dot we have written 2 that specify that we want precision of 2 digits. So we want 2 digits after point, and then F specify the format as a floating point. In above case, D represented as integer number, so here F represented format as floating point. So together this creates this entire line. Once this entire line is printed, this for loop will run for I is equal to 2. For I is equal to 2, this entire line will be printed. For I is equal to 3, this entire line will be printed, and it will goes up to line 5. So after line 5, this for loop will end, and then again we are writing fprintf slash n will jump the cursor to new line total. So it will print this total. Then again dollar percentage dot 2f represents
a specific format as floating point number with precision of 2 digits after the point. And which value it will replace? It will replace the value of this total. And what is the value of this total? We are specifying over here. It is the sum of all these transactions. So now we'll close it. We have entire program. Let's run this entire program. And now we are over here. We'll just open this transaction report. So this is the file that we have created using this MATLAB code. If you want to see the same file, you can see over here. Just minimize this file and just double click this file. The same file you can see into the MATLAB script. So here, using this fantastic command fopen, we have write the file. Hey, if you're looking to find different ways to load your Excel file into MATLAB and then plot those readings, then this is the perfect video for you. The simplest way to import Excel file in MATLAB is just go to this Home tab and import data. Click on that, a window will pop up. This is my folder MATLAB 2017B, and over here in this folder I have this Excel file diode reading. So I'll just open this Excel file. When I open that Excel file, another window popped up. It is just looks similar to an Excel sheet. Through this popped up screen, we can import the data in MATLAB. So now let's understand what it is. These are the readings of forward and reverse bias characteristics of diode. So over here at the top section, the name of the file is represented, diode reading. Now each of the heading that I have provided into Excel sheet, it has been represented over here. Let me show you the Excel sheet first. This is the Excel sheet that we have imported. A blank space and VF, IF, VR, IR and all these datas. Now let's jump to the MATLAB. So here all of these are taken as variable name and you can see this variable name over here. And these are the data in that Excel sheet. If you want to update the name of this variable, you can update it from here. Whatever name you want to give, you can update the name from here. Now, by left clicking and dragging, you can select the data range. I have selected the full Excel sheet. So the data range is from A3 to D14. So full data will be imported to MATLAB. Now import selection. Once you click this area, it will import all the data. Just click it. The following variable were imported. So all these variables were imported to MATLAB. Let me show you that. See over here, diode reading 12 cross 4 table variable has been imported to the workspace of MATLAB. Now, instead of importing entire table, you can select column vectors. So each of the column will be imported as a separate vector data. And now you can import the selected VDF, IDF, VDR, IDR. All the variables were imported as a separate column vector. Let me show you that. So here you can see all of this variable has been imported as a separate variable. The difference you can observe over here, that entire table has been imported in table format, whereas each of individual variable has been imported as double format. So here data type is double and here the data type is table. Now let me show you something else. Just click on this view and from here you can select different views. Just select top, bottom, and over here you will be able to see there are two sheets in the Excel file. It is sheet number 1 and it is sheet number 2. If you want to import sheet number 2, then again select sheet number 2 from here, go to import and column vector. So it is VF, IF, VR, IR and just import these data. Now let's go to MATLAB and now you can see all the data has been imported. If you want to import selected range of data, then you can select a fixed range and you can import that much data only. Now we'll close it and go to MATLAB script file. Now here we have all these data. To plot the graph from this data, it is very simple. If I want to plot graph of forward bias characteristics of diode, I'll just simply write and run. It will ask me to save. Oh, this V is small. Let me make it capital. Now let's run it. So this is how you can simply plot the important data. If it is not looking nice, then you can add and run again. So the graph is clearly visible. It is one of the methods to import the data from Excel. Now let me show you some other methods. That method was very simple and we are directly importing data from the Excel sheet. Now let me show you some other techniques. Using some command and through some script you can import the data. For that, let me remove this thing. I'll write, so run this thing so it will clear everything. So first what we'll do, we'll import the data. This is the sheet we are importing. Open the full sheet I want to import. So done. Entire sheet I have imported. So it is in a table format. Now what I'll do, this is in a table format and I'll save as .mat file. So diode reading is the name of my file, .mat. So now that .mat file is over here. Now I will load that .mat file. So now we'll run this thing, and once we run, this file will be updated as diode reading.mat file. Now in this diode reading, let us check. The name of the variable is VDF and IDF. So what I want to do is I want to load only these two variables, VDF and IDF. So let's load these two variables. So once we run these lines, these two VDF and IDF variable will be stored in Workspace. Let's run this thing. So this is diode reading table. It is IDF 12 cross 1 and VDF 12 cross 1. And over here you can see both of the variables. Now we just simply plot. And there we go. This is the graph. If you do not want to use this plot command, you can select these two variables from here. Go to plot and select plot. And directly you can see the graph has been ready. So this is another method to extract variables from your table variable. Now it might be tough for you all that every time you need to load this variable and do all these things. It's being a little bit hassleful, and maybe many of you do not like to import this Excel sheet through this tab, right? So for that there is another method. Now let me implement that method. So to implement that method, I will write a small code to import the data. So now we are going to import entire Excel sheet through commands. First of all, we'll clear all these things. So everything is clear now. Now we are going to import everything through command. We'll give name of the data diode and the command is xls read. Now into bracket inverted comma, you need to write the name of the file. The name of our file is diode underscore reading. So let's add it. So this is the command xls read and just run. The entire table has been imported just by writing a small command. We have seen that in that Excel sheet there were two sheets. Let me show you that. This is our Excel sheet and we have two sheets over here. This is sheet number 1 where we have readings of VDF, IDF, right? And in Excel sheet number 2 we have reading of VF, IF, VR, IR. To differentiate, I have multiplied this current reading with 10 so we can have a two different set of readings. So it is sheet number 1 and sheet number 2. Now again let's get back to the MATLAB. Now, if you want to import sheet number 2, then you just need to write comma 2. Just add comma and 2, it will import sheet number 2. Let's do it. For that, remember that I have multiplied those readings with 10. So you can observe over here, the reading will be different. Let's run this thing and see. The second sheet has been imported. If we change it to 1, now remember this reading and run. And you can see the difference. So now sheet number 1 has been imported. From that sheet, if you want to import particular set of data, that also you can control through this command. Again, get back to that Excel sheet. The data is ranges in between A3 and D14. Now I do not want to import entire table. What I want is I want to import this much of data, A3 to B14. So let's import this much of data only. So from sheet number 1, A3 to B14, and let's run. I forgot this, and run. So this much of data has been imported. So this is how you can import selected data, multiple data from Excel sheet through only one command. Now let's again import a full table. So let's run, and we have imported full table. Now from this table, if you want to extract different variables, then over here you have did it in one manner. Let me show you another method. Here the table is stored in diode. So let's write VDF is equal to diode matrix into bracket. This is the diode matrix, right? Let's open it. This is our diode matrix. So from this row 1, I want entire 12 rows. So I'll write gem for entire rows. And I want only column number 1. I want all the rows and only column 1. So comma 1 bracket over, and let me run this thing. So all the rows but only one column has been imported. The same way if I want to do it for IDF. Now the IDF is in column number 2. Now let's observe, run it. So it is VDF and it is IDF. Now now we do not want to observe this. So just suppress it and run. So this is the graph. To make it look appropriate, so this is the graph, how it looks like. Now up to here, we have learned how to import Excel sheet. You can import this Excel sheet only if this Excel sheet diode underscore reading.xlsx is in current folders. But what if your Excel sheet is somewhere else or somewhere in another folder? So how to import that Excel sheet? So now let me show you that thing. So we'll comment it. We'll write a small script for that. Now let me take you to some another folder where I have kept another Excel sheet. This is my temporary folder on desktop. This is the Excel sheet called reading. I'll open it. It is the same Excel sheet, right? Reading is the same Excel sheet as previous one, but that Excel sheet is in another folder, and the folder is temporary folder, and this folder is on desktop. I'll right click it, go to properties, and I'll show you this path, location. I'll just copy this location, copy, okay, and go to MATLAB. So first of all, we need to apply a path. So we need to tell MATLAB that where exactly my this Excel sheet is. So for that, we'll write a code, path, comma, into inverted comma, we'll paste that entire path. bracket over, and now we'll write name to the variable diode1 and we'll apply the same command. In that folder, name of our file is reading. So let's run. Diode1 data has been imported, and if you want to see the change, let me update some data over here. I'll give it 1 2 3, and over here I'll give it as 3 8 14, just a random data. Save it. Let's jump to MATLAB. Say this diode1 table. Now let's run it again, and this is the updated table. These cells were empty, so it is represented as NaN. And after importing this Excel sheet through this way or through this way, whatever you are comfortable with, you can plot whatever type of graph you want to plot. Now, before ending, I would like to ask you a small question. When you directly load Excel file in MATLAB, then what will be the data format? Your options are this. Think, try to recall, and choose your option wisely. Do not forget to write the answer in comments below. If you want to learn anything more on MATLAB, just write that thing in comments below and I'll make video on that topic.